Hello, interwebs. Eventually, I finally figured out the daylight savings thing. So I apologize for any, any confusion on that. Could we not just go to some kind of a universal thing? It just seems crazy to me.
It would be nice, but
Yeah,
then there
wouldn't
is
it?
relativity too.
Before we dive into this, let me just check with the chat and make sure that our volume levels are okay because I tend to I tend to have fun with that as we go. So if people wouldn't mind in the chat, just letting us know how our volume is. In fact, we could test it by saying, Gaetan, welcome, and maybe you could let us know who you are and what you do.
Thank you, David. Hello, everyone. So I'm Gaetan Briand, and I'm a microelectronics engineer at the European Space Agency.
Which sounds it just sounds so concise and simple, and yet there's an awful lot going on there. Like I had no idea. I mean, I guess I sort of knew that things had to be a little different when you get them out in space, but you are having to deal with sort of errors that we're not having to deal with here and whole different types of unique customized systems that we don't have, that we don't have to worry our little pretty little heads with here, right?
Yeah, but that's the interesting thing. Some of the technology is already almost ready for that. So you just have to know which switch to turn on, and a lot of the time it's all good like this.
Yeah. It's and how to okay, so let's we should go back. We should go back. How
Yeah,
on
maybe.
earth do you get into this? Like how do you get I mean, I could look, I understand the excitement about, about the idea of like programming computers and stuff. Did you start at a hardware perspective or did you start at a software? Where did you end up? How did you find yourself at these little these sort of programmable chips?
Yeah, but it just arrived just like this because I was doing my studies, and yeah, as we discussed last time, I really liked a lot of everything related to STEM. So I was trying to learn a lot about a lot of things. And at sometimes everything gets super complicated when you have all those big math formulas and so on. So that's when I was a little bit struggling, and I tried to focus more on the topic that I was interested in,
Mm,
and that's where I ended up in my engineering school. So that was focused more on electronics. That was
mm,
something that was interesting for me. And and at some point, I discovered we had some courses also about microelectronics, and I discovered, especially on the digital side, that it was really something appealing. And I just dig a little bit into it because, yeah, I was thinking, oh, I found it easy, like I've already done that somewhere. And that when it struck me, it's basically, if you have already played Minecraft, it's like the redstone in Minecraft.
mm. Yeah, we were talking about that before. The idea that you were programming stuff in Minecraft. I mean, using the redstone is fantastic. I think it's a and as an educational tool, I think it's brilliant too because it really gets you excited about the idea of programming, basically.
And it teaches you about microelectronics because, yeah, that's the difference also between software and hardware. Because here in the redstone in Minecraft, you already have the little notion of hardware. Because if you have your redstone signal that is more than 15 blocks long, you don't have anything anymore because you
Yeah.
need to boost it up. And it's just yeah, it's kind of what we do in microelectronics. You need to be aware of the design that you are doing, otherwise it won't work.
Yeah.
And that's a little bit the trick because, yeah, when you're talking about software, about hardware, and some people, when they look at what we do in the microelectronics, especially on the digital microelectronics side,
Mm.
they think it can be software because the way we do it, we abstracted everything to a way that it's quite similar to code.
Right.
And
Right.
the thing is that, as it's similar to code, people that know software say, "Oh, it's an if. I can do my if,
Yeah.
my
If
loops, and
then the
so on."
loops. The yeah. Yeah.
The thing is that for a for a software engineer, it would be an if is basically, if you go behind it, it's a branch instruction in a processor, just
Mm.
saying go to this next memory instruction and so on. But if you look at the same code in our coding language,
Mm.
it's something more like it's what we call the multiplexer. So basically, it's a logical gate that that gets a signal from one side, a signal from the other side, and you just choose which one you put to the output.
It's but
That's
that
the quite a big difference.
I love the way you make that sound simple. I it's it's funny because I looked at you. You sent me you sent me on a little quest to uncover the flow, the microelectronics flow, which I thought was really interesting. We should step back though. Let's step back for a second. What exactly, like, what is it? What are you doing? Like, what is what's all the hands-on day to day job that you're doing at a sort of a higher level for us non microelectronics nerds?
Yeah, so on the ESA side, my job is, as I'm part of as it is, sorry, as at ESA, we are here to help the industry do the projects
Right.
and research more. My role is more an advisor. So I look at what they did. I give them advice on what they should do to make it better, and so on. So the day-to-day basis is not that hands-on.
Hmm. It's not that. It's so funny how often I talk to people who I guess maybe it's a level of people we're talking to, but that how much of it has moved away from the actual. You must, but you surely you don't you like you must get your hands dirty sometimes. You must want to get in there and play with some of this stuff yourself.
That's the thing. I was discussing with some of my colleagues about that because some of my colleagues really love to get the hands-on, and we have an amazing lab to do that with all the technology you want to try. So it's really good. But the thing is that my path was more on the, I when I started, I really loved designing. I really loved being my
Hmm.
hands-on and so on. But then I went back to, as I said at the beginning, I really like to learn a lot of things and to know a lot of things. So I
Yeah.
really try to learn a lot and to get a bigger scope. So basically, I started as a designer. I move also to verification because, yeah, that's something we can talk at some point. The verification of microelectronic design is really something super important
Hmm.
because of the cost of producing any device in
This
microelectronics.
is like verifying it before you build it type thing, or
Yes, that's it. We have all those tools of simulation and so on. And yeah, basically, yeah, if we talk on that, the thing is that when you put the design that you made into the silicon,
Hmm.
doing that costs a lot of millions
Right,
already.
right. You want to get it
So
right on paper, so to speak, before. Yeah.
that's it. If you screw something up, you know that you have to repay those millions.
Right. Right.
So
Wow.
that's the thing. Once it gets produced, once you have the initial layer, it's far cheaper. That's why everybody can have a microelectronics chip in their phone or everywhere because
Hmm.
yeah, that's the thing that you
They're
produce
mass produced. They're
millions and
mass
so on.
produced.
So
Yeah. Yeah.
yeah, it's but the price of doing that is super expensive. That's why what one of the important thing is to be sure that when you will get to this stage, it will work or it
So
has a high chance.
does that mean you have really very good sort of virtual tools available to you then? You must have things that are pretty perfect at making sure that things are working before you actually have to go to the actual process of building them.
It's both tools and methodology because yeah, there are some companies and some people that are also developing methodology for this
Mm,
verification
yeah.
that are available, that are open source for most of them, and you can reuse them. So because also you have a lot of communication protocol
Hmm.
that are generic, so you can easily make something to drive it
So there are
and
libraries of
reuse it.
stuff that you can use then.
Yeah.
Yeah. Okay. But are you using but you need to know more than you need to know what's happening in the libraries too, right? Like can you I'm assuming you can't just like cut and paste someone's, little system onto one of the nodes or whatever within the chip without knowing how it works.
You can and you cannot because yeah, as also it's super expensive, and the more you get in the more complex technology, the more expensive it gets.
Mhm.
Uh, Also on the development side, not only on the production side. So sometimes we have the concept of what's called IP cores. So it's basically someone is doing the block,
Yeah.
describing it, and is giving it to and it hands it to you, and you just plug it in your design, and you don't have to develop this functionality.
Huh.
It's working.
So it's almost
So
like object oriented in that it's in their each their own little standalone pieces as much as possible.
well,
That's a
yeah,
no. That's a no.
yeah,
Just for everyone at home, that's a no.
No, it's more. I would say it's more like Legos. It's once again, it's
Or like
hardware.
Lego. Huh,
So
interesting. Yeah.
I'm
Yeah,
more
that's
used to
true.
get
I
some
keep making it into
hardware.
software. That's so true. I keep making a jump into software. It's so funny.
So it's more like Legos because it basically gives you
Mm,
a Lego brick and you plug it to the rest of your design
mm.
and you get a nice Lego construction.
And so what's neat about becoming more of a generalist on this stuff is that you become the funnel to funnel that stuff into a usable tool. I guess that means you can communicate with various different departments to get them what they need in this kind of a situation.
Okay, so yeah, getting more generic in here is having an overview of more the things I was telling you about the design, about the verification, but that's what we call the front end. So that's what is really and that's why people mix it up with software is
Mm.
what is really far from the from the what we call the backend, so from the physical layout on the chips.
Right, right.
So, yeah, my last position before joining ESA was a SOC architect, so it's a little bit fancy. But basically, I was the guy looking at some Lego bricks and putting and advising putting people on how to put them together and follow that blocks of Lego blocks all
Huh.
the way to the physical chip and to send it to the foundry to make it real.
It's fascinating because I remember my interest with computers originally was hardware. Absolutely hardware. Like I loved, when I learned that you could actually build your own computer, I was like, woohoo. And it was it was complicated Lego in that nothing ever worked. Originally there were all sorts of, interrupts and stuff that had to be worked out. But I loved that. And I loved it so much that I felt like I got to a point where there's a connection between where you get so low that you're basically becoming the software side as well. And I then went back up the other side to all the software and the programming and stuff. So where did you start? What was your so Minecraft? I mean, was Minecraft, was it early enough that Minecraft had an effect on where you went with this stuff?
Uh, I think it was by luck. It was one of the courses at my engineering school. I saw that. I say, yeah, it's exactly the same. So
Yeah,
let's do it. I already do it for my pastime. So let's do on that. And
yeah.
yeah, I was super happy that my school had everything there because you had we already in the school we already have a lab to be able to make our own chips. Let's
Oh,
say.
really? Oh, wow.
By the way, yeah, I have the what we call
Hey.
a wafer. So
Yeah, yeah.
that's basically so if people wondered that's the kind of no, let me take it out if I don't break it. No. Yeah.
Yeah, don't break
So
your history, but yeah.
yeah, so basically it's a
Wow.
round thing like
Yeah.
this. So basically at my school we were able to do those. So this is a basic thing. This is just a capacitance like you could see in everything. So
Wow.
basically when you produce a chip, when you go to the production phase, you get basically a big disk of silicon.
Mm.
So that's like this. And so yeah, actually, it's a really old technology that we had at school because yeah, we can spend millions just because two
Right.
students
Right,
need to
right.
make us chip. So basically now you see this is quite a small thing. Now when you produce chip, it's more 20 centimeter or 30 centimeter
Wow.
size of things. So yeah, basically you have we're able to do that in the school. So I was so it was super nice also to see all the process over there. So yeah, that's all
Wow.
to say that in the school we have all the resources to go through that. And yeah,
How do
I
you
want
make
you to
them? Like, how does one make a chip like that? Like, what's involved in that?
okay, so yeah, basically that's the disk that you saw. It's what we call a wafer. So it's
Mm,
basically just silicon. So it's basically sand that was cleaned from all the impurities
mm,
and melted and so on. So then you have this big disk, and
mm.
then what you do is so from the coding style of that I explained you before, you
Right.
go a little bit deeper. So you add the timing timing information between all those logic blocks and so on. You
Mm,
go lower and lower, and at some point you map it to something that other people did, and basically the logical gates they exist basic block of logical gates, and we have a whole process to go through there. And then all those logical gates to put them on the wafer. The thing is that we just make transistor on this. So
Right, right,
transistor basically is it's switches that you can control
right.
with electricity. So
Yeah, like
so
one input, a tiny bit of electricity can control larger amounts with the other two. Is that basically it? Is that the transistor thing? One
yeah,
signal will basically route things.
yeah, basically the transistor you have three, yeah, you have three input three input output. One you say on or off, and the
Yeah.
other one is the signal that is passing on it.
Right, right, right.
So based on that, you can make the logical gates
Mm,
like the one that you have in Redstone in Minecraft.
right.
And with all those logical gates, that's what makes your chip. And then yeah, to put it on the wafer, like I said, it's big fabs that do that. And basically what they do is they take the wafer, they put what we call a mask, and they send beams of ion to create impurities, and they change the mask, and they do layer by layer like this.
Oh,
And
wow.
and that's when you manage to get all your chip with a lot of different layers. And by the
Oh
way,
my God.
when I tell you that that would cost a lot of money, it's those masks that cost a lot of money, because
Mm.
yeah, you've heard that
And they've got to
about the
be,
technology that yeah, now we have 3 nanometers or
I
so
know,
on
which is
technology. So
insane.
you need to draw all that stuff that is only not, it's actually not 3 nanometers, but that's another talk. That
Mm.
you have to draw all those things to be able to then have the perfect chip.
Wow. I guess I didn't realize that you're basically kind of you're basically changing little levels of the silicone to create the form that you need to make these things.
Yeah,
That's God, that's amazing. But as you say, you don't want to be it's not like a 3D printer. You're not doing that, oh, that one screwed up, let's do another one. That's a lot of you don't want to if that etch is wrong, if that mask is wrong,
yeah,
that's an expensive process. Wow.
it
Yeah,
is.
no wonder you've got very strict and flows for this stuff. That's amazing. Okay, take me back to a kid. You're a kid. You're running around as a under 10-year-old. What are your interests? Where you I mean, where did you where on earth does this come from?
Yeah, I think I was a fan of video games, science fiction, and all those stuff. So everything that is high tech was really
Yeah.
a good thing for me. So that's
Yeah.
why when I told you I needed to restrain a little bit the topics, that's why where electronics seemed to be the good
Yeah.
thing, you know.
Yeah. It kept you that could keep you interested. And were you soldering your own stuff and doing your own little kits and stuff? What was the how did
That
that sort of
that's the thing. I was always afraid to break something, so I was not the kind of kids that was doing all that.
yeah.
But you know that's the kind of thing. When I arrived at ESA, I started to do this a lot more, because I said, now, now I'm doing spaceships. What can I? Why won't I be able to do
Yeah.
those small thing around the house that I always push to?
There you go. You don't have that excuse
Uh,
anymore. Now you got to actually
yeah,
fix things. It's interesting, isn't it? I my fear of breaking things was not as strong as my curiosity to take them apart. So I'm afraid I ruined a lot of very nice things as I grew up. And one of the things I did with the Tech Bandits was to sort of introduce them to the idea of like get finding e-trash, like finding old computers and stuff. And instead of just tossing them out or recycling them, why don't we sort of pull them apart and see how they work? Because that really worked for me. And the idea that you don't have to worry about breaking stuff, because breaking stuff, it is like, I mean, and also I think parents are very good at sort of going like, because they've spent the money on it, right? So I think you pick up on that. But that's interesting. So your wow, so your interest in this stuff was was sort of removed from the actual physical process. That's kind of neat.
yeah, because I was just feeling that, yeah, I don't know the stuff. I'm can't. It felt so far, you know,
Yeah.
to be able to work on those stuff and so on.
Yeah.
Even now,
Well, it's so complicated too. Like it just if you look at it from afar, it just seems, they look like little cities on chips. I don't know how anyone
and
makes them.
even from close, they are super complicated.
It doesn't get easier. The closer you get, it doesn't get easier. That's funny. It's interesting though because but it just seems funny that you went into the hardware side of stuff, given that you're approach was very software by the sound of it.
It was not that software when I was doing in Minecraft. It was Redstone, and actually I never did software before going to my engineering school. We
Really?
are doing some math programming, I guess, or something
Mm,
like that when I was before, but yeah, that didn't attract me when I
mm,
started engineering school and we started to have those courses. Yeah, it was I kind of liked a little bit the
mm.
programming, but every time I was when I was starting programming, I was, oh, look, there is a why do we do all those inclusion of all those things? What are those things? I was always wondering, what is that? What is this thing?
Mm,
What is that
mm.
thing? And then when you go down to the, as I said, to the level of
Yeah.
instruction of the processor, you say, but then that makes sense. And as it makes
Interesting.
sense for me, that's where I said, okay, I prefer to be there and to be the
Yeah.
guy preparing those processor to do the calculation, and
Mm.
someone else will do the part of the calculation.
So were you was assembler something? I mean, you must have done some assembly.
Yeah,
What is
yeah,
your
yeah.
favorite? Do you have a favorite language? Do you have a favorite language you use?
As an hardware engineer, I will say VHDL or Verilog, which are the
Oh
language that
wow.
we use to describe to describe
Yeah.
the chips. But
I've never played with it. I looked into it because we were going to talk, but I was like, "Ooh, okay, that's a lot of YouTube videos before I start making any sense of that." But it's and that, is that sort of like that's I guess that's the industry standard for this kind of stuff is Verilog.
it depends on the domain actually, because a lot of people are doing Verilog on even the higher level, which is system Verilog, but on the space side, we are more on the VHDL part,
Mm,
because and everything that is space, you need to be really strict on everything,
yeah,
and
yeah.
the VHDL language is more strict than Verilog.
Mm,
And now you have also heritage and so on. So as I was telling you about the IP blocks, when you reuse some blocks like this,
mm.
they are in VHDL. So yeah, better to do everything consistent.
Right, right. And is that? I mean, what's the learning curve like on that? Like, is that something that I could sort of get a sense of by playing with it myself, or is there a better route into that?
I guess you can get a few FPGA for not that expensive on the internet. Of FPGA, yeah,
Mm,
it's a field programmable gate array.
yeah.
Basically it's a chip that we produced to be
Mm,
able to program other chips in it,
right.
not program to configure other chip in it.
Right,
I'd say.
right, right. And those, yeah, that stuff's always fascinated me. But it's but they just seem like such completely different tools from, as you say, from what like, well, my favorite thing right now is Python, which of course is as far removed from that. Well, and no, I would go further than that.
Not
I don't think it's Python anymore. I think it's actually the natural language programming that you get using like Claude Code and stuff now.
okay.
I
Yeah, but
love that.
it's not that far, because Python we use it a lot in different domains, because
Mm,
yeah, for example, there are some, I was telling you about some verification methodology available on the internet. Some
mm.
of them are written in Python, for
Oh,
example.
oh,
And
really?
also, when you do verification, one of the best thing is to do the same thing twice,
Mm,
but in different methods. So usually we do the VHDL description on
right.
one side, and then sometimes you get a Python library running in the verification environment, and the Python is supposed to do the same thing like your VHDL, and then
Mm.
you put the same input and you check what you get, and you say, okay, it's the same thing, then my VHDL works.
Right, right. Wow. So
So yeah,
what was
but
the path? Oh, sorry. Go. Yeah, yeah.
for your question about is it okay to get to it, if you are used to software, you can try to get to it, but
Mm,
then you will have the problems of when you press the button to go to the FPGA, you will have the problem. Oh, I can synthesize this because you didn't think about the chip in a way of a chip. You thought
yeah,
about it
yeah.
as a as a as a software engineer. But
Mm,
on the other side, redstone is a good thing because you draw a circuit basically.
mm-hmm,
And one of my teacher was always saying you need to think about the design you are making.
mm, mm.
So every time we were telling him, oh, I don't think that it work, can you help us? He was looking at the code and he was saying, what? what are you thinking of?
What are you
And
trying
then
to do?
you
Yeah.
just take your sheet of paper, you just take a pen, and you draw all the different boxes, like you would put
Mm.
the different component, the redstone component in Minecraft, and then you have the thing. And that's one of the things that I was telling you about, because yeah. We do the description in VHDL, as I
Mm.
told you, and then we go to and then we go through a process that is called synthesis.
Mm.
And basically, that's where we map what we described in VHDL,
Mm.
in or in any other description language. In the We map it to some predefined libraries. So to the because depending on the technology, you have different size of transistor and so on. And someone
Right.
already did the OR gate on the AND
Right.
gate
Yeah. You don't want to
with
reinvent
the
the
correct
wheel if
size.
it's already
Yeah.
exists. Yeah. Yeah.
So we just have a mapping like this. And
Mm.
yeah, as I was telling you, when I was doing my studies and was starting getting interesting in all that, I saw also that there was someone that made a synthesizer that gets you VHDL description to Redstone. So
Oh,
th-
wow.
that's the
Oh,
kind of small
yeah.
link you can get.
That's neat though. Like I love that as a teaching tool though as well because it just seems so it's just such an obvious connection for people. Like if you like doing this, you're going to like doing, you're going to like doing that. Obviously at a higher level and stuff. But so what was the journey from to get to ESA? How did you end up at ESA? How did you end up in space? Wait a second. Yeah, hold on a second. You're designing chips. That's not my first thought isn't like, "Oh, how let's hurl these into orbit."
Yeah, that's exactly my beginning of the beginning of my career. I was just trying to get a job with that thing that I like
I just
doing. So
needed a job. Yeah.
I got my job. Yeah, it was kind of 10 years ago now, I think. But I got my first job, which was microelectronics and just microelectronics. So I was
Mm,
designing, I was doing the thing, and yeah, as I told you, I wanted to get more and more knowledge about everything. So
mm.
SOC architect was kind of the
What is sock
highest technical.
architecture? What is that? We've used that term before. What does that mean exactly again?
Yeah, it's when you take the different blocks and you make the Lego out of it, and then you advise everyone in the team how to create the design from this
Okay, so
to
so basically it's a symbolic system for what you're
yeah.
then going to do. I got it. Okay, right.
When I told you drawing box is important, I was the guy drawing box and saying to
Right.
people, can you put that in the computer,
Yeah,
please?
yeah. Yeah, yeah. Put it in the box. Put it in the box. Does it fit? Yeah. Is it so okay, so the ESA job literally just came up because it just came up as a job. You hadn't been planning on the space side of stuff originally or anything.
It happened to me, yeah, because I was a SOC architect and I was looking around in my company and I was trying to say, what can I learn more
Mm,
with my skill set? And I was saying, oh, I don't have anything more in this company. So I was
mm,
trying to start looking at other stuff. And as I already had a job and everything was stable, I said, okay, maybe I can do something a little bit risky and maybe go more to some other things that I like. And
mm.
yeah, as I told you, sci-fi and so on, you get interested in space.
Yeah. It's kind
And
of hard not to be, isn't it? I mean, I don't know how anyone just ignores space. Like it just.
yeah, at some point, I think one of the things that happened is I was still doing this job, and at some point I was looking at YouTube, and I found a video of someone doing some kind of a television journal and explaining everything that is happening in space. I look at this, I just hang them and I look at it every week. And at some point, yeah, when I was in my job and saying, what could I do next? I was remember this and I said, oh, so let's maybe there is a job that is close to what I do. I was not expecting finding microelectronics direct job,
Right, right.
because when you think about a spacecraft, you don't think about microelectronics first.
Ha.
So
I do now.
yeah,
But yeah, yep.
so yeah, I was looking at all that, and I just look at the ESA website, and I type microelectronics. Maybe there is some job that needs microelectronics, and it's a small character print at the bottom of the page. And then I found this job that's called microelectronics engineer. I said, that's even better. So I clicked on it, and it was quite kind of close to my job on
Mm,
the SOC architect side because the as I told you, where we're giving advice to everyone, and as a
Mm.
SOC architect, you think about the chip and you give advice to everyone
As
so
a
that
whole,
everyone
yeah,
works
yeah.
together and gets to the end thing of the chip.
Mm.
So yeah, I applied. And by the way, that's some people contact me on LinkedIn sometimes, some students so on, and tell me, yeah, maybe I don't know how should I do to get into ESA. Yep, just apply.
It's a good start. It's kind of hard to get a job if you don't. Yeah, was it?
Yeah,
It's like it's hard to win a
because
lottery if you don't buy the ticket. Yeah.
I was not really expecting to the thing, and I was thinking, okay, so let's try this. It's my first interview in a long time because I've been working for several years already, and I've not done interviews in the meantime. But yeah, let's start this because I'm looking at this, and if I'm kicked out of this, I will try other maybe space
Mm.
companies that are around, and yeah, and I got selected. So
That's fantastic.
I think one of the things that helped is also that yeah, I was into space and I was following those news on space.
Right.
I just I had the space knowledge, and
Right.
they asked me about the space knowledge, and I also knew a bit of what happens to the chips
Mm.
when they are exposed to the environment
Oh
of
yeah,
space.
which is wild. That's a whole. We got to get into that in a second.
Yeah,
But so you raised an interesting point though, because it's something that I've seen people do where people will not look. They're like they're looking for jobs. They're not sure what to do, and then they see something that they absolutely want, and they do their interview, and it could go well. It could not go well. Who knows? I'm always like, apply for everything. Apply, because you can have like 5 or 6 different interviews to get really good at interviews before you finally find something that's absolutely your thing. I mean, it's a bit like auditions. I always consider them like they're like messages in bottles that you throw out to sea. You never know where they're going to float up and land and who's going to pick them up and look at them and go like, oh, that guy, he should be whatever. That's great. Was it a big adjustment then getting to ESA? I mean, was it a big change from doing the
it,
soft?
it was quite a change because
Yeah.
before I was everything studies, first job, childhood, everything. I did it in France.
Yeah.
And then you go to a foreign country. I was super happy because the Dutch are amazing. They all speak
I
English super
know.
well and so on.
Yeah.
So
They all speak like
just
50 languages.
yeah, I heard you discussing with other people and saying that every European is speaking a lot of languages, and I'm a bit ashamed because I speak super good, nah, super good French, of course.
Mais
You may have
oui.
noticed
Yeah.
with the accent,
Yeah. Yeah.
and quite well English just because I got
Right.
training here working with Isa.
Yeah.
And yeah, that's almost all. I'm trying to do a little bit of Dutch because yeah, they are super nice and
Yeah,
talk
but
to
you speak
English with me
computer.
sometimes, and I
Yeah,
prefer.
you speak
Yeah,
yeah, you're talking
I
to
do speak Python too, so
exactly. There you go. So, that's a I mean, it is a language. It's a funny thing about programming I find is that like languages, if you don't use them all the time, I find you just don't retain it. We're not built that way. Our brains don't work that way. I mean, it's like no, it's
But the good thing, I have a I have an office mate that is Spanish, and when I
mm,
was a child, I studied a bit Spanish. So now we are trying to and he has a French wife, and he studied in France. So we just noticed that we have 4 languages in common. So
yeah.
French, English, Spanish, and Dutch because we're both trying to learn Dutch.
Yeah, yeah.
And we put a schedule on our whiteboard in the office and saying, okay, this day we speak in the office in French. This day in Dutch, this day in English, this day in Spanish. So yeah, I'm struggling on Fridays because it's the Spanish day, and on Tuesday, which is the Dutch day, he usually works from home to avoid issues.
Yeah, no one talks. No one talks on those days. There's like complete silence, work in complete silence. That's hilarious. I love that the engineers though, like that, that you're putting together boards of when you're speaking the right languages and stuff. Someone on set was called said was there was one of our actors is European and someone was like, "Oh my god, he's so smart. He speaks like 6 languages." I was like, "That's not smart. That's European." That's all. Of course, I've got one. So, yeah, that's
And
right. And
French,
is yeah.
you just spoke French.
I see my French. Oui, j'ai étudié la français pour toute ma école, mais I don't know what the word would be. Comme dit, failed. I
Échoué.
was it?
Échoué.
Ishwit. So that every year, I was in summer school every year for French. I hated it. And then as soon as I left school, like as soon as I left school a little early, I the first job I had was in Quebec, where they speak a type of French, an ugly French, but still French.
Ah,
It's and I could pick up little words, and I loved that. I mean, I've got to get back on the what is it, the Duolingo train. I got to get back on that. Um,
yeah, I'm using it for Dutch.
yeah. So you were and so where's home for you? Where was originally home for you?
Okay, so all my childhood it was in Nantes, so a city that is on the west coast of France,
Yeah,
close to the Atlantic.
yeah.
And then for the studies, and I stayed there 10 years at least.
Wow, wow.
It was in Grenoble, so in the middle of the French Alps. This is
Oh,
the French
wow.
Silicon Valley.
Yeah, yeah. That's
Because yeah,
amazing.
we have our foundries there. The school, as I told you, yeah, it's about microelectronics too. So
Mm.
yeah, there is a lot of
What
things
was the
about
school? What school
microelectronics
did
there.
you go to?
It was called FELMA, so for physics, electronics, and materials.
Wow,
That's good. It's the same in
boy,
French and in any
that is a
language that
lot of
just works. So it
nerds.
works.
That is a lot of nerds. That's great. Okay, and so when you get one of the things I noticed when I was at ESA, which just for the open day stuff, was was exactly what you're saying that you enjoy, which is this lots of different things. And I feel like there are so many people, and I couldn't get over how many different entry, trajectories you could have going into this field because it covers everything.
Yeah, and I'm super happy because also, yeah, for me, as I told you, I wanted to broaden my range, and
Mm,
microelectronics, it's everywhere in a spacecraft.
yeah, yeah.
So
They're
that's
basically
super.
computers in space. I mean, that's yeah. The other stuff just keeps it going.
Every time you need to think a little bit, that the spacecraft thinks a little bit,
Mm,
you need microelectronics. You
yeah.
don't do it even if you need software. You need the
Mm,
microelectronics that run the software.
mm, mm.
That's the chicken and an egg, because you need microelectronics to run software, and you need software to produce high level microelectronics. But at least you know which one came first. It was microelectronics. Just saying.
Is there any way? Oh, I see. We've chosen the egg. What about? Uh, are there? I mean, are there sort of hardened CPUs or anything? Are there any things? Are there some standard computers to some extent that could be sent up?
So yeah, we didn't discuss exactly about the problem that we can have in space.
Yeah,
So yeah, that's why you talk about hardened computer,
that's
because the main.
The C problem. Is it called? Is it C? It's something about the where the basically the ones and zeros are mixed up by radiation of some sort.
Yeah, SEs. Yeah,
Yeah.
we use the three letters.
Oh, sorry. Yeah, yeah, yeah. I'm an actor, so I use words.
So yeah, that's yeah. There is the main issue for space component is radiations. So
Mm,
you have a lot of different types of radiations. Some of them are like you see the SEs. So basically, it's when there is a particle that comes at the wrong moment in the wrong place,
mm.
and you have your one that is stored in memory. It becomes a zero, or the other way around.
Which is
And
insane. Like I don't know how you possibly. I can't wait to hear how you solve that.
we try. Sometimes it doesn't work.
But it's
No,
totally
but
random, right? Like, or is it not?
yeah, yeah, it's totally random.
Yeah.
It's galactic cosmic ray, so it's
Mm.
coming from really outer space, or it's the sun, or it can be everything. It's particles trapped in what is called the Van Allen belts. So
Yeah. Yeah.
it's radiation belts that are around Earth,
Mm.
and so yeah, they can happen anywhere. And the easy thing is that yeah, we use democracy basically.
Mm.
We use we do the things 3 times, and then we ask them, guys, what is your answer, and we
Mm.
take the majority.
Huh.
So that's the way to do it. You can also do it a little bit smarter, a little bit smaller, and just ask two and do the things twice and ask the two people, but you won't know which one is the right one or which one
Yeah.
is the wrong one.
Yeah.
But in
Yeah.
that situation, you can say, okay, you are not agreeing, just do it again and tell me again.
Until
So
you settle on a solution.
there is a lot of
Wow.
techniques, but yeah, the main one is the what we call TMR, so the triple majority triple TMR. Oh, we call it TMR.
Yeah.
So basically, yeah, you do the thing twice, 3 times, and then you vote at the end to select the majority thing, and this is more likely to be the right answer.
But that means you need basically 3 computers for every computer.
Or you need the chip to be done in the way of inside with 3 times everything. But and basically that's as this triplication and so on is something that is quite you can apply it quite easily. That's what I'm telling also to people that don't work in the space domain, because I'm also helping companies that are starting in the space domain. Is the goal of ESA to help the companies. And yeah, I had some people that were super afraid of starting on space and was afraid of doing everything. I told them, yeah, guys, just think about your design as you usually do. Just try to think that it takes more space than usual, because you will do everything 3 times and a majority voter.
Right. But then you're covered. But then you're basically covered.
And the tools are made for this. Basically, you can do the basic design, and at the tool, the synthesizer that I told you about before, the one that is translating from our description methodology to low level, this tool, you just put a command in there saying, okay, do the triplication for me, and then you have your old design.
Oh wow! So it's just right. Okay, all right. But it's just something you do have to consider going in.
Yeah, but that's the ideal case. You always have in between things, because yeah, it's 3 to 4 times bigger. So
and 3 to 4 times more expensive every time you do that, I imagine, as well, right?
No, it depends. But yeah, as it's 3 to 4 times bigger, and it's also slower, because basically you have more things to do the same stuff. So the signal, instead of going from point A to point B, it goes to point A through the majority voter to point B. So it's slower to get there.
Right.
So everything is slower. So
of course,
have less performance.
Right.
And then you lose performance. You lose the compactness of your design. So that's where you need to. You sometimes you see application where they need really high performance. So then you say, okay, let's do it in another way. Let's not put any triplication, and let's make the calculation of what happens if I have a failure at if I have a failure there, and how much time will it takes me to detect it, and then to reset everything, to restart the thing again. So yeah, you need to find a balance. It really depends on the application. So
this stuff's got to be changing pretty quickly, I'm guessing, right? I mean, like in the same way that, when I started programming, you had very, very limited memory that you could work with, because the chips just didn't, I mean, they were prohibitively expensive if you wanted to do anything more. Whereas now, you've got basically, we write code in such a sloppy way now, because the computer makes up the speed for us. Is there a time when, is it going to be like cheap enough to send something up that's 3 times or 4 times the size, that you can sort of relax on some of this stuff, or is it going to become more and more important to optimize?
I think we are touching a little bit the global scale of the space business, because until recently, the space business was, you make one satellite, you fly it, then you make a completely different satellite, you fly it. Now you see with with what is called the mega constellation, they do the same satellite hundreds of times, and they fly it hundreds of thousands of times, and they fly it. So we used to, for the one time satellite, you cannot do your own chip, because as I told you, the highest cost is what we call the mask, and doing this mask costs too much money just for one project. It's almost all the money of the project. So you
like
can't
only governments and the such can afford that kind of stuff, I'm assuming.
Or mass production, but not space satellite that are one time done. So what we was doing is what we call the FPGA. We already talked about it. It's the field programmable gate array. So it's so we design a chip that people can put their configuration and make it work like their own chip.
Right. So, and optimize it for whatever it is that they're doing.
Yeah, so you're losing the performance because basically how it's done, it's also basic blocks that you
Mm,
can say, okay, now I want this one to be a AND gate. Now I want
mm,
this one to be a NOR gate.
right,
So you can configure everything like this. But then as the OR gate is here, the AND gate is here, when you need to pass the signal through them, if they are far away, you need to go all the
right.
way through the signal
It
and you
becomes
have
more
a
of a
lot of delay.
generalist than optimized for anything specifically.
Yeah,
Right.
while you do your own chip, you
Mm,
need an end and an O that communicates. You put them as close as possible,
right, right,
so you have no delay between them.
right.
So that's why we needed to use FPGA. You have
Mm,
less performance, but you produce one chip and
mm,
you use it for multiple applications.
mm. And are they going to space? Are those the ones that are going to space?
Yes, a lot of them are going to space, and there is a different kind. There are kind of FPGA that were made for space.
Mm,
So all the things that is like the triplication that I was telling you about,
mm,
some of the FPGA creator already thought about it. So
mm.
when you use their stuff, you don't even need to know anything about space. You do a
Right.
normal microelectronic thing, you put it in there, it's already protected
Mm.
from radiation. So it's all good.
And does that mean you can adjust things once it's up there as well? Like, does that mean you could? Do you have any?
That's
Because
a
you
really
couldn't
good
do that on a
question.
CPU, right? You couldn't do that if you sent a, you sent a Pentium up there. It ain't, you can't change it once it's there.
Yeah, that's a really, really good question. And so that's something we are currently in a big change of mindset,
Oh.
because before the technology that we were using as FPGA were one-time programmable. So basically,
Mm,
it was fuses for the configuration.
mm,
So everything was super reliable and you could fly it, but not no reprogrammation at all.
right, right.
Now we are in two different types of technology. So the flash based and the RAM based.
Mm,
So the flash based is like the flash drives and the memory point. So
yeah,
it's non-volatile memory. So you can do your
you can
programming.
change it. Yeah, yeah.
You could do it again. It's not done that much because yeah, sometimes you have troubles with the programming
Yeah.
logic that
Or every
needs.
time when I try to flash things, but yeah, yeah.
No, but on the space domain, yeah, you can have some troubles with the programming logic that is
Mm,
less performant regarding radiation. So
right.
if you program on flight, you are more likely to program garbage.
Oh, yeah,
So it is
yeah,
a little bit dangerous.
yeah. Okay. So
But
what's the
yeah,
other option?
the other option, the flash and the RAM, the RAM, it's not. It's volatile memory, so you need to reprogram it every time. So then they thought more about the way to
Mm,
reprogram it to make it if they are space capable
mm, mm.
to make it smarter. But yeah, so, and then so you can program them not having to worry more about the radiation effects on the programming side, because it was
Right,
also made for it, because they know that you will have every time you have to reboot, you have to reprogram it,
right,
to
right.
reconfigure
Okay.
it. I prefer to say configure because yeah, once again,
Yeah.
it's not software, it's hardware. So you
Right. I know
configure the
it's such,
FPGA and yeah.
but it's so funny because you're right. It's like you've almost got one foot in each camp doing this. Like you're kind of right on that edge between human and computer, which to me was always fascinating. I was always fascinated in assembly. I just didn't have the patience for it because I was like, oh, for God's sake, that's just to get it to do one little tiny point on the screen. Does it take forever? It's fine. I should try it again now that I've been playing with the Claude stuff because I'd love to have it teach me some of that stuff. I love that. Um, so what is your current project? What are you working on right now? Or are there multiple ones? What's on the schedule for you right
Yeah,
now?
as in my team, we are supporting
Hmm.
all the project from the agency. I'm supporting a lot of different projects, and as I told you, there is a lot of FPGA or ASICs. It's more FPGA
Hmm.
on all of these missions. So I'm supporting a lot of FPGA in a lot of
Yeah,
missions.
no kidding. How many? And I'm guessing they have different ones for different sections of different, even on the same satellite. You're going to have different.
Oh yeah, oh yeah.
So how many? Give me a number. Like what? Like roughly, how many of these things are you dealing with right now?
I'm dealing with something like 6 or 7 missions. So
Wow.
missions is satellites or launchers or things like this. And in them, it depends really on the project. But yeah, at least five FPGA every time,
Wow.
and usually more.
So you're dreaming about this at night.
I try not.
Well, you're good. Yeah, we got to talk about your. We'll have to talk about your extracurricular stuff after. But you're. It sounds like you're good at. Well, like most Europeans, I find good at separating, but enjoying both of both work and play, so to speak. Um,
Yeah, I think that's an important topic, and I think it depends on what you are doing and how much you are passionate about that. Because yeah, every before I really liked the way of working with microelectronics and everything that I told you about, but I was not passionate about microelectronics. So
ah,
in my previous job, I was really good at saying, okay, now I've done my job for the day. I'm going home and I stop everything.
right, right.
Now I'm also passionate about space, so I still have the connection to work,
Yeah,
and it doesn't bother me sometimes if someone send me a message about work
right,
late
right.
or early to just answer him. I won't open my computer most of the time to do something, but I'm less detached. But as it's a passion, it's
Yeah.
less impactful on your life. But I really feel like if it's not a passion, you should really try to get the distance, because yeah, you
Mhm.
need your own time also.
Yeah, absolutely, absolutely. I mean, what's so funny? I mean, this is just such a complete difference from what I do on a not a daily basis. So that's part of the problem that I have is that if you were acting every day, you wouldn't have time to do anything. But the fact that I don't act every day allows me a lot of time to which I think you can waste. This is just fascinating because I get to talk to people who are doing stuff that that I didn't even know existed before. I mean, it's so funny because you really have you were talking about how people don't think about there being these basically computer chips in everything that goes up there. I think about that all the time now because they really, I don't even think of them as satellites anymore. I literally just think of them as like, flying laptops. Like it's just, because everything's like that now. Like, I mean, that's, your fridge, I'm sure there's probably intelligence in the microphone I have. I feel like it's everywhere. I mean, are there other areas that you find are you drawn to any other areas where this stuff's being used?
Mm,
Or do you basically
yeah,
get to access that by in the job you're in now?
I think it's more in the job that I am in now that I really like it, because yeah, before, as I told you, when you do chips, the goal is to make a lot of them to
Mm,
make it to make it useful. There is a lot of nice challenges about that, because you need to have some chips that you can easily kind of print to be sure that on your wafers or
yeah.
on your disk, that most of the chip works once they are produced, because there is always sometimes some of them that don't work because there was a particle of dust that came
Yeah, I didn't
along
realize
at the
that
same
either,
time.
that was the different editions of chips and things that they're like, those ones don't work on that part, so we'll sell them for it's
Yeah,
extraordinary.
that's the Intel things. You have
Yeah.
all the different ranges of Intel, and basically, what they do is they take the chip, they do the test, what we call the hardware, the test vectors,
Mm,
and with the test vector, they know, okay, this one is slower than the other one, so I'm going to put it in this bin,
yeah.
you call it. This one is there, this one is there, this one is there, and let's package them, and let's sell basically they sell you the one that is not really the one that they wanted, but it's
Yeah.
still kind of work for a smaller price.
Yeah,
But
I couldn't get over that. I mean, it's genius, but I mean, I guess at some point they used to just toss the stuff away, but I mean, no,
yeah,
it's amazing.
it's super important, because the bigger your chip gets, the more probability you have that there is a failure somewhere.
Right, right.
So the bigger your chip gets, you need to be thinking about that. The last project I was doing, we were thinking about that a lot, because yeah, we were discussing with the company that was producing our chip, and we were saying, and at some time they were saying, yeah, those have a lot of high failure rates. Those
Mm,
are also, and you can have these things that fails. And I was thinking at that time, okay, but if those things fail, you don't really need it. You could use all the rest of the chip and
mm.
just don't care about this thing. So we discussed at some point, should we make different bins to say, okay, this chip works
It's
completely,
good
this
for this.
chip
That
works
yeah.
works without this functionalities, this one
Huh.
without that. But then it's also a matter of cost, and it's also costly to have
Mm.
different sorting and to have all the process behind to say, okay, these medium chip, let's package them this way and write on them that it's this processor and so on. So
Really, it's like not good for this, that kind of thing. Like that's, I guess it makes sense though. I mean, especially if you need them for testing. If you're testing something that doesn't relate to the part that's maybe not working, I guess you can use that, and it
yeah,
saves you some.
but the thing is that testing takes a lot of time. So
Right.
when you test, you basically it's just you put needles on your silicon. You
Mm.
send all the testing that you programmed before,
Mm.
and if you have thousands of chips, you do it for every chip.
Mm.
And if you have thousands of chips,
That's insane.
even if it takes 1 second, it takes in the end thousands of seconds,
Yeah.
and the machine you rent it during thousands of seconds.
Mm.
So
Mm.
if you speed up by half, you rent the machine only
Mm.
less seconds. So
Wow.
it
God, I didn't
costs
even
you
think
less
of that.
money. So yeah, that's something that is super interesting in the thing. You need to have a good
Mm.
balance between okay, let's reduce the test time. But it's super important because if you send to someone a chip that is not working because he didn't do the right test,
Mm.
then the guy will tell you, yeah, you send me something that didn't work.
Right. Well, and we've seen that in the past with CPUs, where there's been ones, there's been all sorts of, uh, errors that have shown up with mathematics, and this. I remember back in the day, there were a number of chips that came out that were limited because they couldn't do things properly, or they'd been, somehow
Yeah, I think
exploited, or.
there was one of the story that I remember about all those stuff about all the company that couldn't make a product. I
Mm.
think it was about Intel and one of
Mm.
and at some point they had a strategy. They carry it on, carry it on, carry it on,
Mm.
and at some point it was consuming so much power that the chip were melting.
Oh
And
wow, wow.
and then you have a full generation of chip that you were working on. You can't make it work because it's consuming too much. So
Yeah.
you have to change your strategy and so on,
It's
or
an
change your
ex
technology.
I
So it's
it's extraordinary to me how, I mean, well, how far and how fast this stuff has happened, but also the future. Like we're basically at the limit now, right? I mean, we're about as close to those little connections are about as close to, what do we have, what you said, 3 nanometers? That's where we're at now. I mean,
yeah, a little bit less. I
we're
think maybe
we're
two.
into sort of quantum entanglements and things at this point. What are you? Is there anything that excites you future wise? Is there any sort of new stuff coming up you've got your eye on?
But
You don't have time.
don't
You got too many satellites to do.
that's one of the thing. And also in space we are lagging behind because we need basically before using the technology we need to be sure that it can be
Right.
space proof, because yeah, we talk about the SEs and so on, so
Mm.
the change of 0 to 1, but you can have other problems like the particle happens at some places and then you have a short circuit and then you burn everything and then
Oh,
you cannot fix it even by resetting. So
right.
that's the kind of thing we need to know the technology and to be sure that it
Mm.
won't have those destructive effects, to say, okay, this technology is working, let's go with it and let's produce chip on that. So that's
Mm.
where, and as we are a small business, as I told you, we don't create a lot of chips.
Mm.
We are using some technologies that already exist because they already have an industrial maturity and
Mm.
cost
Mm.
less.
How
So
mature are
you
they? Like, how many are we talking? Like a decade? Like 5 years? 2 years? What do you need to feel confident about using this stuff in space?
it depends really, because yeah, we're not in charge of everything. So some companies just invest more money
Right.
and some
Right.
technology nodes than other, and then we try to work with them. But yeah, we are yeah, it depends, because it depends on the technology too, because yeah, if
Right.
you talk
It's
about the
not a general.
smaller.
There's not like a general rule that it's got to be 2 years in the field before you can use it for. All right.
No, but yeah, there is a generic. There was a kind of
Mm.
a generic rule to understand how the technology are progressing in the generic business.
Mm.
It was called the Moore's law,
Oh,
and
right. Yeah. Yeah.
ba-
Yeah.
Basically, it was saying that every, I don't remember, every that amount of time, the size of the transistor will be diminished
It
by
like
2.
doubles the, yeah, exactly. Right, right.
So yeah, basically, the when you talk about the technology that is 2 nanometer, is
Mm.
supposed to be the size of the gate of the transistor, if I don't saying stupid things,
Oh,
which is
really?
one of the parts of the transistor.
Right.
But at some point, it stopped being that, and it was more used in a commercial way. So the smaller technology, you don't have a 2 nanometer gate. You
Mm.
have the equivalent of a 2 nanometer
Oh,
gate.
really? Oh,
Because
okay.
before, as I told you, we were doing the things. You put the mask, you put some things on your wafer, and so on. So you create your transistor this way.
Right.
Now it's more complicated. You have more masks because you do 3D structures.
Mm.
So technically, the gate is what used to be a layer that you put on top of the transistor.
Mm.
Now it's something that you put around another layer.
Oh, wow.
So things evolve like this,
Mm.
and then to on marketing side, you can say, oh, we are still at 20 nanometers because everybody is expecting it to diminish. So on the marketing side, they say, okay,
Mm.
what is the equivalent of the density
How do we make these
of the
numbers smaller?
transistor?
Yeah.
And yeah, so
Right. Interesting.
it's a good metric to understand
Mm.
how powerful the technology is,
Mm.
but it's also a little bit tricky.
Right, right. Which of course you're going to come up against all the time because you're looking at it at that level to see how things are going to be affected, I'm guessing.
Uh, yeah, because that's the thing also. Yeah, because the smaller you get, the particle that
I
comes
was going
from
to
space,
say the bigger that
maybe
particle is
it
going to
can
seem. Yeah.
impact more stuff.
Yeah.
So yeah, you need to, at some point, you need to think about, okay, when I do my three ways,
Yeah.
maybe instead of doing my 3 ways, I need to take this way and put it all the way down, take this one, putting all the way up, and
Yeah,
then do
yeah.
the voting a little bit further. So if there is a particle that goes on
Oh,
this one,
wow.
it doesn't impact the other one, because yeah, if you put the 3 next to each other and there is one that is touching two
Mhm.
issues, then your majority voting is going to take the wrong answer as the right one.
Yeah, because there's like a crater where there used to be that connection. But so, I mean, does that mean, so I guess speed is almost not an issue for you. In a way, the stability is way more important than the speed of these things for
Eh,
space.
it depends on the application. There
Right.
are some science application that needs a
Mm.
lot of processing power,
Oh,
but you
right.
don't need to rely a lot on the technology.
Right. Like
So
lightning. Like trying to record lightning, I guess, was one of the ones we were talking to someone about that a couple of weeks ago, where
yeah,
how do you have a satellite that's gonna, you have to record and then process that information on board. And of course I'm thinking like, yeah, no big deal. It's just there's AI for that. And of course you're going like, no, 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 no. I need chips that are gonna work out there. Um
one of my good example is one of the mission I'm working on, which is Vigil. So
yeah.
it's a
Mm,
sun monitoring mission.
right.
It's to check out the solar flare and so on. Yeah, because it's not like in Stargate, you don't have space whales that can tell you that you will get a solar storm.
It's
You
so
need
much easier
satellite
to
for that.
write this stuff. It's just. But wait a second. But that means you're literally like just looking straight into the eye of all of the problems that you've got. I mean, because you're
Yeah,
not protecting yourself from the sun. You're now like facing the sun.
the goal is to work during the solar storm. So when
Yeah.
there is solar storm, there is
Oh
more
my god.
particles.
So
So
what are you
you
doing?
are
Like there's a football field between each one of those. how far apart are those nanometers?
Yeah, on this one, you need a lot of those mitigation technique to be sure that, yeah,
Yeah.
when a solar storm is coming, you can still be able to say, oh, I see a solar storm. Earth, please do the stuff
Yeah.
to
Yeah.
to be protected, because yeah, basically it can have quite an impact, those solar storms.
Yeah.
For example, it can impact the whole power grid, and
Mm,
it could cost a lot of money to the to
mm.
the to the different countries. For example, I think in the UK it's recognized as earthquake or as floods,
Which is,
as
I'm amazed we're so blasé about it. Like I feel like it's like I'm always like, well, isn't that like a huge problem if none of our Earth-based stuff or even some of our space-based stuff isn't able to sort of handle that, like a big solar flare or whatever? I mean,
So yeah, that's the goal of the mission, just to be able to tell everyone, you have a solar flood that is coming your way. Do your safety things,
Oh, that's
because I think, for
fantastic.
example, there was one of SpaceX launch. They had a whole bunch of Starlink, and they just lost all of them because there was a flare happening at that time, and they were still
Yeah.
quite low, and so they
There were
just lost
issues.
them.
There were issues with John Deere. I know not just John Deere, but these very sort of advanced, complex, expensive agricultural tractors and stuff. Were having problems because they're completely based on like their GPS stuff is very specific for lines of corn and all that kind of stuff. So for a while there, apparently there were some pretty wavy lines because of some kind of solar issues. That's amazing. Okay, so how do you so Vigil? Where are you at with Vigil then? What's where how sort of close is that to launching, or is that launched already? Where you at
I
with that?
think the plan of the launch is in the 2030s.
All right. Okay.
And then this one is interesting because it's not Earth orbiting, it's Sun orbiting, because it will
Yeah.
go to the Lagrange point. So the Lagrange point are some balance point between
Mm,
Earth and the Sun Earth Lagrange point. So
mm,
basically,
mm.
it's the one that is going on if you have the if you have Earth here, if you have the Sun here, you have the L2 Lagrange point
Right.
that is behind Earth. Did I say
Right.
Earth? Yeah, Earth,
Yeah.
Sun. You have the Lagrange 2 point that is here and where we put our telescopes. So
Right.
James Webb,
To avoid the light.
they are there
Right.
to avoid the light. Yeah,
Yeah.
and because it's stable, so you don't need to consume a lot of propellant. You
Mm,
have a L1 that is right here, between the sun and the thing. So if
mm,
you are if you want some things that face the sun, you can put them here.
mm.
And we on the Vigil side, we are on L5, which is here. So basically, basically there is a stable point there, and it's fun thing by the way, because for example, if you think about if you replace Jupiter with the Earth with Jupiter, so you have
Mm.
Sun, Jupiter, and then you have this stable point, and we can
Yeah.
see that there are stuff there. The Trojan asteroid, if I'm not saying something dumb,
Yeah.
I think they are one of the some asteroids that are trapped in those
Oh wow.
stability points, the L5 and the on the L4. So yeah, the goal of Vigil would be to be in this L5, because I learned that on Vigil too. The sun is also rotating on
Yeah.
itself. You don't picture it,
You
but
don't
it's
think of it,
rotating on
but yeah.
itself.
Yeah.
So by being in this place with Vigil, you can see what will be in front of Earth a little bit later.
Ooh, so you've got a little bit of a window before.
Yeah,
Oh, nice. Okay.
and it's also super nice because you are at this point. Earth and the sun are here, so if something is sent this way,
Mm.
you are just here to take the picture of everything.
Wow. And what kind of sensors are you using for that? What's going to be involved in that?
A lot of different
A
things. You have
lot.
some,
Yeah.
yeah, you have some coronagraphs. So you
Mm.
hide the part of the sun, and you just see the
Right.
corona of the sun.
Right.
You
Right. You
see a
make
lot
your
of
own
things.
little eclipse. Right.
Yeah, you
Yeah.
have some plasma analyzer. If
Oh
the
wow.
plasma comes to the satellite, you have some magnetometers too.
Right. Right.
So you have plenty of things. I think
That's a
I,
lot
I,
of
I
programmable arrays.
yes, and a lot of ones that need a lot of radiation
Yeah.
protection.
And
But
the protection again will come through that democratic process, or is there are there can you build? I mean, I guess you build some physical shields to this stuff as well. I imagine.
there is always some physical shields.
Mm,
So yeah,
mm.
because you have to encase your spacecraft, you have the structure of your spacecraft, and you can
Right.
always calculate an equivalent shielding.
Right.
Radiation people are far better than me at doing that, but they can tell us, the radiation people, how much what is the probability to have impacts on the chip,
Really.
and then we can say, and then we can calculate other people can calculate the availability and tell us,
Mm,
okay, with this absence of mitigation,
mm,
you will be off for you will be on for 95% of the time. So
mm.
5% of the time of the mission, you will lose. You will not be able to make
Right.
this work.
Right.
And that's how it works at the mission level.
Mm,
we send down some requirements. We say to the companies, okay, we need it to work this amount of time with
mm,
this condition. And Vigil, the condition are super stringent because they say
yeah.
during 1 week of solar event, you need to work that amount of time.
Mm. Is it
So
is it hard to get people behind this stuff? Because like I said, like I'm amazed that we don't make more of the fact that these solar incidents can have a huge impact on the planet. Is there funding for this stuff because it could save them some money?
yeah, that's what I was trying to say before. The UK have that in their list of natural disasters.
Oh, so they get extra funding for I see. So it's like it's like FEMA or something in the States, right? Okay,
Maybe.
wow. That is, I wonder where Canada is on this stuff. Whether we're involved in that at all? Because I know we're an associate member of ESA.
I'm not sure we have any part of the satellite that is built by Canadian company.
Mm,
So usually it means that, yeah, as we have this policy of zero return, it
yeah,
usually means that the funding
mm,
was not coming from this country, and that's why
interesting.
most of the satellite is built by the UK because
Right,
money
right.
is coming from the UK
Ah,
because it's
of
one of
course.
their.
Oh, good for them. Well, that's great. Um, so 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 looking forward. I mean, you're talking about looking forward. You've got to launch in 2030. You're like that. Like you got to be a pretty patient guy. You don't
Yes
seem
and
like
no.
you seem like someone who wants to have things happen now.
That's the thing when you have 7 missions in parallel.
Ah,
This one is in 2030. I have another one next year.
okay.
So yeah,
There's always a fire to put out, so
that's it.
it keeps you interested. I should check on questions. Shoot, I'm sorry. This is so much fun. I forget that there's other people listening. Yeah, I basically just so you know, and so everyone at home knows as well. I just like to focus in on our guests because I'm too distracted to try to go back and forth to chats and stuff. Agne will put them all together into an email, and then I can ask the questions. So I'm sorry if people think I'm ignoring them with various questions. I just like to focus on what we're doing here, and I'll save the other chat for other stuff. Let me see. I'll pull this up. See what Agne's got for us. Speaking of many languages, Agne's got to go and learn Dutch today. That's where she's running off to. Questions. There we go. So I've got a question for. Wow, someone's actually emailed me directly. Okay. Here's a question for Gaetan from Edward Kukukska, who says, "How do you balance cutting edge architectures like Risk V with the extreme reliability requirements of a space mission? The reduced instruction set 5? Is that what that
Yeah,
is?
it's the kind of processors.
Yeah.
You know, you have the basically people think about the Intel processors
Yeah.
that are based on x85 architecture. So it's basically
Yeah.
when we're talking
The
about
old
assembly, it's
dinosaurs like
basically
me. Yeah.
it's basically the way you have the assembly. Most of the system works on ARM architecture.
Yeah.
So it's
As my Mac does now. My Mac is now the new M1, M1 to 5 they're all ARM chips, aren't they?
yeah, even the thing is that people don't know more ARM than Intel, but if you had the sticker ARM inside, you would have them everywhere.
Right, exactly. Yeah, I'm sure. Oh, I'm sure that's
But
true. That's a good point.
yeah, but yeah, ARM, their business model is basically they sell you the design and you put it yourself on the chip.
Mm,
And
mm.
every chip you produce, you give them a little bit of money.
Right.
So
Okay.
producing something with ARM is a little bit expensive.
Right.
That's where some of the open source instruction sets are happening, like RISC-V.
Mm.
RISC-V is a good is a good example, and
Oh,
it's
that's an open source version?
the instruction set is open
Mm.
source.
Oh,
Then
great.
you have
Okay.
a lot of different companies that building some devices on these
Mm.
instruction sets.
Hmm.
So yeah, we are starting to use some RISC processor in space, or at least we have some research ongoing.
Mm.
And the thing is that yeah, it's like everything you need to. If you want a RISC-V processor, you just need just you need the hardening parts. So you can use a RISC-V, but you need to use the mitigation technique. So the
Mm. Mm.
triple majority voter, like we explained before, you can you can do a full chip like that. Yeah. There's another. Ah, sorry. There is another thing we didn't talk about, but you have a lot of memories on those related to the
Oh
to the
yeah.
CPUs, and those memories, they are already done. That's the kind of IPs that you buy,
Yeah.
and
Yeah.
that's IPs that are provided by the usually the one making the chip at the end,
Yeah.
and those you can't really add some things. So or if you add something, it would be super big. So
Mm,
the thing that we do is we do something smarter. We take the word that you want to put in memory. You
mm,
calculate something based on that,
mm.
and when you read it back, you check the calculation, and
Oh
there are
wow.
some smart
Oh,
algorithm
like
that
a
tells
hash
you,
of some sort of that. That.
yeah, something
Yeah.
like
Yeah.
that.
Yeah.
And there are some smart algorithm telling you, okay, if the calculation is wrong when you take the word out,
Mm.
then I can tell you that this one should be a one instead of a zero, so you can
Oh
correct it and send it to
wow.
the rest of the chip.
Oh, that's great. That's really cool.
So yeah, on some processor, you need to think about all that because you have the level of caches and so on. So you need
Mm,
to think about all the memories. But the core of the core that is supporting the RISC-V
mm,
architecture is something that you need that you need the normal redundancy. Let's say
mm.
normal.
Is there an advantage to using sort of, I mean, like, would a hard drive work better than a silicone chip on some of this stuff? Or I mean, like, are there old school approaches to this that are better? I mean, like, as we get more and more advanced and more complicated stuff, is it becoming more difficult to mitigate that kind of thing? Or I guess you just make it
Uh,
up with things like,
yes and no. You have new technologies for the
mm,
memory, for example, that are radiation immune, basically. So you have those
really?
memories that are magnetic RAMs. So they store the one or the zero in the magnetic field,
Oh,
and basically
wow.
this is not affected by the radiation because the radiation
Oh,
doesn't
wow.
change the
Okay.
magnetic state. So yeah, there are some technologies that are appearing that can be better, and
Hmm.
yeah, you can say it's new or old, but you know that the first space mission were already some magnetics.
I know, the
It
coils,
was
that I
the
can't
big
get over
coils.
that.
Yeah.
There was a coil magnetic memory of some sort, wasn't it? It was I
So
remember even as a kid going like, "What? How does that work?" But I guess it's also probably really robust because it's not gonna get knocked out like some of these
yeah,
chips are. Huh. All right, I'm looking for more questions. Here we go. Uh,
it makes me think. Did you read the manga that I was advising you about?
I haven't read it. No, not yet. I was too busy trying to get through your the process, the whole
I
micro.
I should have put it in the mail too.
Yeah, it's true. It's true. Should have put it in my homework. It's true.
But look at
Um,
it. You can have a few interesting things about that, for example.
well, what is it? What is the manga and what's the connection?
Yeah. Sorry for everyone else. So
I know it's so easy to forget that we're not just having a conversation
yeah,
ourselves, which is
last time
good.
we
That's good.
discussed about David, we were speaking about mangas, and I was advising him to look at Doctor Stone,
Oh, right.
because
That's right.
if you are a bit into space and a bit into technologies and
Mm,
science, this Doctor Stone manga is really great. You start from the Stone Age basically,
mm,
and they go to higher technologies,
mm.
and you have a lot of cool stuff in there.
Wow, I gotta
So yeah,
check that out. I gotta. There's just too much cool stuff going on. I can't. It's hard to keep track of all this stuff.
always.
I just started reading The Expanse again because I want to
Ah,
read the second book because I never read the second book, and it's been so long now, and my brain has probably been hit. It might as well have been in space for a while because I'm missing a chunk. So I got to go
watch the
back and
series also.
what? No,
Did you watch
it's
the series?
this. I haven't watched the series. I watched the first couple of seasons and then I sort of drifted off, but I really want to get into the book again because I want to know the nerdy little stuff.
Speaking about actors that come to Estec Open Days, the year before you, there was the main actor of The
I
Expanse that
know,
was born.
I know. I can't believe I missed that. I would love. I mean, it's funny. One of the people I want to talk to actually is Kara G, who was on that as well. Who I did a film with a year or so ago, and want to talk to her about that because it's just it's such a great, just a great the concepts, the space, everything. Agnes got me all obsessed about it, so I got to watch. I got to watch it again. All right, let me see if I can get our questions. That would explain it. I'm in the wrong email. There you go. Okay. I thought there were going to be questions. Okay. Okay, everyone's discussing programming and Minecraft. Aha! I gotta get back into some. I gotta do some more Redstone. God, I missed my Minecraft. All right, Christian Unpronounceable says a question for Gaetan. What are some of the applications his chips are used for? That's a good question. Yeah. What do they get? Everything by the sound of it.
Yeah, that's the thing. You could think about, for example, rocket. Everybody, when you talk about space, you talk about rockets. But rockets, if you have liquid propellants, you need to mix them. Then you need to control the valve that will dispense more or less things. So you need a little bit of smartness that says, okay, I have this pressure in the tank. I need for the rocket to go. I need this to go through the propellant. Then I need to make the calculation to make it go to make it to open or close the valve. So that's the kind of things that can happen with.
And you don't want that going off by one or two here or there.
Yeah, that's one of the things. Have there been
catastrophic failures because of these things? I mean, do you know of any? Are there any sort of apocalyptic? I don't know what that. I'm going to ruin that word. But are there any sort of tales of these things gone wrong in the past?
Do I remember them? I don't think so.
There was something about. I know there was one that people got there was the wrong measurement used. Like someone was using inches and someone else was using.
That was I remember that. I guess that was programmed. And the fun fact, I see now some of the mission that I'm working on. One of the first requirements is all units should be done in international
metric.
System in metrics.
I can't believe there's still holdouts. I mean, the Brits are smart enough to think about doing the solar stuff, but they're still using their old. God, it drives me crazy. Don't even start me on that, Gaetan. Okay. Sigma Crier says, how do you test something on Earth that's meant to work in an environment we can barely simulate? What's the biggest difference when designing for deep space missions? Oh, wow. Yeah, I guess there are different requirements depending on how close or far away we are from the planet.
Yeah, and so about a deep space mission and not deep space mission. So you can think about, as I was telling you, you set some requirements saying about the availability of the chip, and then you can get, depending on where you are, what is the radiation environment, because we already, especially in Earth orbit, you have all the measurement of all this stuff is. So you know what's the environment, you know what you want to do, and then depending on that, you make your calculation to say, okay, I need this, and this. And you could think that it can be more dangerous for deep space mission, but deep space mission, depending on where you're going, it can be also easier because for example, if you go in L2, you are behind Earth almost always.
You got a giant rock in the way. It's perfect.
Yeah, but on the contrary, if you go to Jupiter, we talk about those Van Allen belts that takes all the radiation from the sun and just store it around Earth. The magnetic field of Jupiter is far bigger, so you have far more radiation belts, and you have far more radiation issues, trapped radiation around there. So you have more.
So your positioning even there is going to be, I guess, you're going to try to find the optimal position for that too, I suppose, right? Where it's most protected, but still able to do what it needs to do. Can you hide behind anything or partially behind anything while you're out there?
Yeah, sometimes you have some shielding really done for on the spacecraft for the electronics, and then you can think about your trajectories and make it smarter. So, for example, I think it's on the JUICE mission. We are going to some of all the moons of Jupiter.
Yeah.
Some of them are closer and more exposed to those trapped radiation. So that's the one that we go fast. We don't stay that long.
I'm out of here. Yeah, that's right. So you go faster to avoid. Oh man, it's like there's so many different things to think about, isn't there? I mean, it's sort of So go ahead.
Yeah, no, so that was the question. It was about deep space, and there was a part about how you test on Earth, if I remember
Yeah.
well.
Yeah.
So, yeah, radiation, you can make it happen on Earth. So we have some facilities, and that's some interesting thing. You have some facilities that are here to test some of the part of the radiation effect. So one
Right.
of the radiation effects we didn't talk about was total ionizing dose. So basically, as some of the particles that can impact your chip are ions, it's basically something similar to the process of creating the chip. So
Oh,
you're
right.
adding some
That's why it messes with it. Yeah.
yeah. So with age, the components don't age that well because you are putting some things like you are producing the chip, but randomly. So
Mm.
the characteristic changes, and so to test that, you put the chip close to a radiation source,
Mm.
and you have some really smart people about radiation that can say, okay, this radiation source, it's emitting a lot of radiation. It's equivalent to that amount of days in that orbit.
Mm.
And then you take the chip back, and then you do your measurement and so on. And you can say, okay, on the TID side, this component should work.
Mm.
And for the SE, I think so the thing 11 effect, the one that
Mm.
flips the bit,
Oh
I
yeah, yeah,
think
yeah. I don't know why that's my favorite for some reason. I don't know why, but yeah, yeah.
it's my favorite too.
Yeah. Is it okay? All right.
So you can have issues with there are a lot of things that can do this effect, including some protons effect, and sometimes you want to put them on the thing. And then that's something that I learned. You know, for treating cancer, you sometimes get you are sometimes treated
Yeah,
with
radiation.
some radiation.
Yeah, yeah.
You use exactly the same thing, and you put a chip instead of a person, and then
Oh,
you test it for space.
oh, wow. So it's basically the same kind of units. Can you use the same units? Like, are they literally the same? Like, you're not taking these into the hospitals to try them out. They're like you've got your own facilities for that stuff.
Uh, there is a lot of needs for facilities, so there are
Mm.
facilities that are dedicated for space, but I think there are sometimes the use of more generic facilities. You also have particle accelerator. Yeah, I know how to
Yeah,
mime the particle
yeah,
accelerator.
yeah.
And
We're
then you can also test your chip there. So there
mm,
is a lot of ways to test it. I'm not an expert on that.
mm,
If you manage to have someone from radiation team,
mm.
you can ask them all about this. But yeah,
Yeah, it'd
they
be
are the smart
interesting,
guys
wouldn't it?
saying that's the equivalent between the space environment and in this orbit, and the particles that we can throw
Mm,
to your component, and then you can check it. And that's how we discover some chip that have those burning failures, as
mm,
I told you. And then you say, okay, this chip, we might not fly it because we know that under those radiation it burns, so we need
mm.
something more reliable.
Interesting. So you don't have to fling the stuff out into space to test it.
Nope.
You're able to do that here at this point.
Because we have quite some data on the space environment,
Right.
thanks to the previous missions
Yeah.
that mapped all those radiation effects and so on.
So you've just got like a lookup table. Okay, it's going here, so that's how much radiation we get from there. Interesting. Okay. All right. How are you for time? Because I can go on forever. But you're how you
I can
all
go
done?
on for a long time too. I
Okay,
just
good.
need to switch on the lights because it's getting dark. But
Look at that. See, wait till you get you need your daylight savings time. Okay, here we go. Agne's got a question. She's always got good questions. From everything, oh, that is a good question. From everything that you've worked on, what is the project you're most proud of? I mean, without getting yourself fired or in trouble, I guess. But is there something that stands out as like, wow, that was
so
freaking awesome?
there are plenty of things. Uh, so Vigil, that's something that I was not aware. Like we were discussing at the beginning, I was
Mm.
not aware too about all those trouble that you can get because of the thing that you don't see much in the Netherlands. But
That would be the sun. Yes, got it. Yeah. We're not seeing a lot of it here either. Don't worry about it. Yeah. I don't know where it's gone.
uh, messing with satellites apparently.
Yeah, yeah,
So yeah, this one's super interesting, and also that's one of the things with my domain. As we are really low level of the satellite, we are usually called on a low level basis, so we don't see a lot of the thing. And this project is super nice because they are including me also in every step, so I can see a lot of things, and I'm super grateful for them.
Oh,
They are
fantastic. Is
it's an
that not
amazing team.
normally how it works then? So normally you get brought in only for that specific little wafer thin thing.
Yeah, we get a lot called for the specific things. So
Hmm.
that sometimes it's important that it's just limited because we have so much work
Mm,
that you can't really see everything. And in Vigil, the good thing is that I have access to everything, but I don't have the time to look at everything. But
right,
yeah,
right,
I can at least have a lot of good conversation with everyone from different background because yeah, I'm part of the team.
right.
But yeah, some other things that I'm super proud of is yeah, I'm as a science fiction guy. You're also super proud if you're able to 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 be part of the big missions that are
Right,
super mediatics and so on
right.
because they are carrying astronauts. And currently, I'm working on part of the gateway station
Oh,
from ESA.
oh, wow.
So, for those who don't know, the Gateway Station is the station that is supposed to orbit the moon for the Artemis program.
Yeah.
So I'm working in this one and one of the European module, and it's super interesting, and especially because a lot of satellites you have the same things. Let's say you have the same modules, you have the propulsion, you have
Mhm.
the communication, you have the structure, you have it's quite similar. In those space station, you have additionally the fact that you need to keep the people inside a little bit
Humans.
safe.
Yeah, you got
Yeah.
humans. You got bags of chemicals to look after. Wow.
So
I've
that's
just
one
had
of
a
the things
quick
that I was
I was going to say
super
a quick
super happy.
goodbye to Agne because Agne is taking off to
Oh,
do her course now. So she's, thank you,
good luck with
Agne.
the Dutch.
Of course, Agne is the one who organizes all these. So she's, huge thanks to her. Sorry, Gaetan, go ahead.
Where was I? Yeah,
You
so super
the
happy to be part of one of the modules for the gateway station.
well, because you're
So
not
yeah,
normally dealing with humans, are you? I mean, in with your
there is a higher probability to deal with non-human because a
yeah,
lot of spacecraft are not human.
yeah.
From the yeah, when I was discussing with some of my friends before coming here, a lot of people see when you talk about space, a lot of people see rockets
Yeah,
and astronauts,
yeah, yeah,
but most of the job is satellites.
yeah, yeah.
So you have a higher probability to work on satellite, and that's also why I'm trying to get the project to see everything. And as I told you, I'm working on launchers, the space station, a lot of
Mhm.
satellites, and yeah, you have also Earth observation. And yeah, by the way, that's a can I say that I'm proud of everything that I'm doing because
Yeah, no, absolutely. I mean, I would be too. That sounds amazing. But
because
it's
for
no, but
example, there is a
yeah.
sorry, go ahead.
No, 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 no. Go, go, go.
I was just thinking about one of the other project that is flying in the coming years. I think that's the one that is supposed to fly in 2027.
Mm.
It's a Earth observation mission, and that's something that we are really good in Europe about Earth observation
Yeah,
mission.
yeah.
And just working with the team, you understand why because they know what they are doing, and it's
Right.
something that is just incredible. It's the mission is called LSTM, and it's supposed to monitor the land surface temperature. So land surface
Yes.
temperature monitoring,
Yeah.
LSTM. So and basically you say why do you want to know about the temperature? If you look at the correct wavelengths, the super smart thing that the scientists can do, they've noticed that you can understand if a plant has enough water or not by just
Yes.
looking at some wavelengths. So basically this mission, the satellite will fly around Earth and just look at the crops and say, okay, and send the data, and those data are available to everyone. Most of the
Wow.
Copernicus one are, and you can say the farmer can say can just look at the data and say, oh, I don't need to put any water on this part of the field, but I will
Mm.
need to put some over there. So let's do that. And this way, and especially you see that water is an important resource.
Yeah, and getting
So
more
you
important.
can,
Yeah.
yeah, you can make it super more efficient the
Yeah.
way you're looking. So yeah, uh,
Is that a
the thing,
series of a series of satellites, or is it like, or is it a
yeah, it's a
constellation?
constellation of two satellites, if I remember well.
That's fantastic. I'd seen a bit about it. I'm not sure if it was specifically this one, but that certainly that it was possible to do that. But that, yeah, I mean, that's extraordinary. It's so silly because when you think of, well, when I think of space, I always think about looking out that way. But the
Yeah,
reality is,
me too.
the most value in a way is looking back at us, because that's, I mean, that's got the most sort of practical effects on our future, like going to check out solar flares before they happen. Just makes, of course, it makes sense. You know what I mean? I mean, it's nice to know how that giant star is working for us or against us. So, more questions. Let's see. So, Agne, great question. Very good. Sigma Crier, question for Gaetan. Oh boy, it's a long one. We're seeing a massive. Oh, I love you, Sigma Crier, because this is one of my favorite topics. We're seeing a massive push for AI and high performance computing in space. As an SOC architect, how do you balance the need for speed with the fact that smaller transistors, 3 to 5 nanometers, are physically more vulnerable to single event upsets? Wow, someone knows their stuff. From radiation. Are we reaching a physical limit? We sort of touched on this, but are we reaching a physical limit of current hardware technology and materials for how smart a satellite can actually be?
Mm, okay, that's a really good question.
Yeah.
So if we talk about the AI stuff, so yeah, about AI, you have a lot of AI accelerator that can be done too.
Mm.
Uh, on the microelectronics side, AI is not something super groundbreaking. It's basically the thing that we were doing for processor for decades now, but
Right.
simpler, and you put more.
Right. Right. And specific to a specific task as opposed to general tasks.
Yeah,
Yeah.
yeah. It's just a 2 or 3 operation compared to a processor that can have a lot of
Right.
instruction.
You're not
So
chatting with your satellite.
no,
Right.
but yeah, the goal is the more complex you have the instruments, the more data you will have to get down to the ground.
Right.
So that is also a little bit tricky because you need to process a lot of data to compress it correctly and to send it to to send it to the ground how you can. But if you process everything on board,
Mm.
you have less data to transmit. So
Mm.
that's a lot of missions are trying to do such things. So
Mm.
simplifying everything that you show them to ground. Sometimes for the scientific community, you need all the data because you
Yeah.
need to understand everything. So then you can have different modes. The nominal mode where the satellite is sending just everything compressed and
Mm.
everything well shaped, and you have the advanced mode where you have where you put every data,
Just dump the raw
every raw
data.
data,
Yeah.
and down there. So that's the thing. And yeah, from my stock architect point of view, it's just a matter of balancing everything. Once again, you
Mm.
need to first have your requirement telling you what is the thing that you want to achieve,
Right.
what is the performance, and in this case the performance is important. So you need to check the performance, you need to check the availability, the reliability regarding
Mm.
radiation. You need to try to find a good balance, so to try to harden some parts and not harden others, because yeah, for example, the part that is the main part of the mission, the one that has the compressed data and so on, this
Mm.
one you need to harden it because you need the data, you need it to be reliable. But the
Yeah.
raw data, for example, you don't need to treat it, so maybe you can store it there and download it from time to time, but not protect it that much. So
Mm.
that's where you gain a little bit by not protecting everything. So
Mm.
that's where you need to do everything. And yeah, the smaller technology nodes, they are not flying yet.
Mm.
The 3, 4. So I'm not sure we have a lot of data, but I have seen in some conference a lot of data about 3 nanometer, I think.
Mm.
So we're starting to have the data, but the data is the first step
Mm.
to create the systems and to put them up there.
So the three
Uh,
nanometer is up there now, you think?
no,
Or not
I
yet?
think it was tested
Oh, I see. I see.
in the
Okay.
different facility that we
All right, but it
discussed
hasn't
before.
actually been used out in space yet. Where are we at with, like, what kind of nanometer are we, just for our own reference? Where are we at
Uh,
with, like, the, like, Vigil or something? What's that going to be using?
A lot of different things actually. As
Oh,
there is
really?
a lot of different
Yeah.
type of FPGAs used. You have now in space we are working up to 7 nanometers.
Oh, okay. That's
On the European side, so everything done in Europe, you because it's important to have something close close to home.
mm-hmm.
We have we have a lot of 28 nanometers.
Mm.
So you have you have
Wow,
this
7 or
technology range.
28. Wow. It's quite a
Yeah,
range.
quite a range, but it's two different technology. As I told you about
Mm,
the structure of the transistor. The one that we use in Europe, the 28 nanometer, for example, is the what we call a silicon uninsulator. So
mm,
you have the silicon. You have an insulator base on top. You have silicons, and then you have all your construct.
mm.
That's the kind of thing that you can think about because, yeah, the problem that creates the radiation effect is that the radiation, the particles are eating your chip and just changing
Right.
the conductivity and everything
Like
of that.
bleaching,
But
like almost like bleaching a poster or something, the way you get that fading.
yeah, yeah, but if you have an insulator, it
Mm.
doesn't have any impact on the insulator. So an
Ha.
S silicon and insulator technology can be a little bit more reliable to those radiation.
Oh, interesting.
So that's why you have a lot of different technologies, and you can do a lot of different things. It really depends on what is your final application.
Mm.
If you want something super high performance in a super reliable mission, I tell you, it will be complicated. You will
Right.
have to make some trade-offs.
Right. Right. Yeah, it's all that's the reality. Is we always want one solution to something, don't we? But the reality is, it's always about a trade off with these things,
Yeah,
or anything for that matter.
yeah.
Uh,
It's not a nice answer, I know, because you are saying something. Yeah, maybe or maybe not. You can do this, that, that. Yeah, I'm sorry, there is not a clear answer, but yeah, that's really dependent on
You only
a
get
lot
clear
of
answers from people who don't know what they're talking about, I find. People who don't know everything are very good at giving you definitive answers. Sorry, a bit of
things.
a bit of an out there question, but you talked earlier about watching videos on this stuff. Are there resources out there that you like? I mean, obviously Redstone, Minecraft stuff. I'm definitely going to look for programming in Redstone because that'll be fun. But were there any other people or things or books or anything that sort of struck you as particularly interesting or
That's a
particularly
good
useful?
question. Uh, Useful. My studies were super useful, so study. It's good.
Very good. Okay. Yep. Yep. Studying tends to help.
But then, yeah, the thing is,
There's
the
no
way we work,
definitive guide on this stuff or anything.
the studies give you a pretty good one. But yeah, as it's a high level technology, it's always evolving. So
Right. Right.
there is plenty of stuff. But yeah, just something a little bit different. The way you need to think for thinking about logics like this, it's something a little bit different than than what you normally think.
Right.
That's one of the things that I really liked at the beginning because yeah, you just have to reorganize your mind so that it works a little bit differently to be able to see everything the right way. And yeah, so do redstone is a little bit fun, and you can have this, but just on some magazines, I remember you have some small logic games, and just having those logic games at the beginning, it makes you think about it makes you think about things differently. And I remember when I was doing those stuff when I was a kid, it was a little bit strange the way you need to think about it. But when I went to work, I said, "Oh yeah, that's also the same way of thinking." And yeah,
Ha.
it's super interesting to have a different way of thinking. And yeah, that's why I really liked it because yeah, it's really something you don't. It's not the way you think
Right. It's
normally. You think,
puzzles. It's like it's puzzles that force you to think about things from different perspectives. It's amazing.
yeah.
Yeah.
But about more serious resources, I don't think I have anything in mind. Yeah, I already struggled to send you something that is viable.
No,
But
that was
so
great. No, that
on.
was amazing. I mean, I had to, I was struggling through it, but again, I think what I liked about that was the whole microelectronics flow stuff was just seeing how it really is different. Like software, you sort of sit down and just go like and bash out stuff and see if it works. This is a very different. You've definitely got to sort of start from. You got to start with a plan. I mean, that seems to be well. It probably helps to do that with programming as well, or writing scripts or whatever. But it's not something you can really do without that plan, right?
Yeah, yeah.
So
You need to first thing you need to know to do whenever you do something is to draw.
yeah,
Just take a piece of paper and draw how you think everything will connect and how everything will
it's
discuss.
funny, isn't it? I have I have a thing where it's just if I want to remember something, I have to write it down. I may never look at it again, but it just locks it. The process, the physical process of drawing things, or it for some reason it locks it in for me. I've never been able to do it digitally. Like I want to be able to just like talk to my phone and have it remind me about things, but I just find things don't lock in the same way without that slight amount of work related
Yeah,
to it.
I remember when I had back in school, the best way for me to, I think it really depends on the people. The best way for me
Mm.
to remember things is just the way I wrote it the first time, because I remember that, oh, this thing that I'm looking for, it's at the top of this page that looks like this.
Yeah, yeah.
I'm looking like this in my mind, but
It's that
yeah.
slightly photographic element to the memory. I find it with I do when I'm learning lines. I'll often if I find myself losing losing a line, I could just picture where it is on the page, and that will often help me bring it back, which is weird. I mean, I'm getting worse as I get older, but like I say, I think my memory's definitely struggling more than it used to. But now that we're talking about these things, about the creative side of these things, you say you're a sci-fi fan. What stuff? What do you like? What are you watching now? What have you enjoyed? What's your poison?
So yeah, I met an actor at the open days last year, for example. That remind me that Stargate was a really nice show that I liked when I was a kid.
My
Uh,
marketing is done.
so no, just th- we already discussed it a little bit about it in
Mm,
our pre-talk, but
mm,
yeah, I remember you said the first time you said that you were saying, as you are an engineer, I would guess that you are kind more of a Star Trek fan. And I told you that I was more a Stargate fan, but I thought a little bit more about this because I have a lot of friends that are also Stargate fans,
mm,
and I just thought about it, but I think it's also related to the accessibility of this series. And in
mm.
France, I don't think we had an easy access to all the Star Trek things. But
Oh,
Stargate
interesting.
was on the main channel, and
Oh, and you had a
you
great actor
your
doing the
voice,
French version of me. He was fantastic. Yeah. I met him.
yeah,
I met him in
oh,
Paris. Yeah, yeah. That's
yeah.
interesting. So availability, it was more.
I was thinking that you were talking a little bit strangely first
I
time we met.
know, I know. I sound so American. Oh, that's great. So, but yeah, I guess the Star Trek thing I was surprised at just because normally, I know for myself, I loved Star Wars, but I loved Star Wars in a kind of a dreamy way. Whereas Star Trek, like both the original series and then TNG was sort of bigger for me. It was and Doctor Who, of course, for me was it was the conceptual stuff. I love that even to this day. Like I wrote my little email of awesomeness last night. Well, over a series of days, but finished it up last night. And and one of the topics that came up was this sort of was this living architecture, and I immediately thought back to, oh my god, I remember that was a Doctor Who episode where the spaceship lived and it could fix itself and breathe, and
That
it just
sounds like a race ship too.
yeah, there you go, there you go. See, so actually that's an interesting question. Actually, the biological computing, is that, I guess that's just as prone to problems with radiation, if not more. I suppose it doesn't really help you, does it?
Biological computing? No, I
Yeah,
don't
like the
know.
idea of using biology as computers instead of just silicon.
As long as you can get ones and zeros.
Yeah, basically that's well they're saying that DNA is a very good way of storing information because it's been stored for millennium like that. Um
Yeah, and we all look different because there are some modification
because of the
here and there.
errors,
So
right? There you go. There you go. Okay, so Star Wars was a good listen to me. Stargate was a big one. I'm very happy that was the case. And I'm
yeah,
glad that you're not a McKay style engineer, because that would be because
actually, I've noticed that I have when I, because I watch all the SG1, all the Atlantis, and now I'm on the universe and
oh
all this one.
wow, God, okay.
Yeah, it took a lot of time. but but rewatching Atlantis, I thought to myself, maybe the McKay ways transferred a little bit on my side, because I didn't remember that, but McKay is always trying to eat something.
Oh yeah, yeah, yeah,
A-
yeah.
and you will talk to my
Me too.
colleagues or my customers, and I'm the same.
Yeah, yeah.
That's the thing, you know. as an engineer in front of your customer in my previous company, you need to be a little bit serious and so on. But at some point, the guys were just making a little bit fun of me and just saying, "Okay, we see that you are hungry. Let's go to the restaurant."
Get a
Because yeah,
snack.
I was the one eating the most every time, I think.
Well, I like to think that it's because our brains are working so hard that we need extra fuel, maybe more than other people need. You know,
Yeah,
that's
I've heard this justification in a series not so long ago.
I'm gonna faint from manly hunger. That's fantastic. Anything else? What are you watching now? What I mean, obviously you've been watching the Stargate stuff, but is
Universe,
there
yeah.
anything else? Any new series that you're excited by,
Yeah,
or
you were talking about Star Trek. So Star
mm,
Trek,
mm.
I started super recently with the new Netflix one, Discovery. I found it
Oh yeah,
really nice because
is that the
the
one
thing
with
that
that's
is
the one with the Klingons? It starts with the Klingons. Which new? There's so
the
many. There's so many new ones now. I can't
it,
keep track.
it was a few years ago. It was the
Yeah.
one with that can cross space through the mycelium
Right.
world.
Yes. I think that was the one that's and it started off with a really weird, very heavy Klingon start, I believe. Yeah, that was it. Okay, yeah.
Maybe.
All right.
But
And you said
I think it was good because the issue I have with starting new series is sometimes you need a lot of background and
yes.
everyone to be able to do that.
Yes.
And I
Yes.
saw that because, for example, the Star Trek, Star Trek Discovery was quite easy to follow.
Mm-hmm.
So I was super happy about that. But then I started to watch the Star Trek show, and there was Star Trek Picard
Mm.
going around. I tried to watch this one, and it was a lot of old reference to the
Yeah.
former series. And this one, I had troubles
Yeah.
to hang to it. And it's also the thing that didn't make it for me on this that series is that it was more old school series, so you had a lot of inside the ship views to save on special effects, while the
Right.
Discovery one was just amazing from the visual
Yeah,
point of
you
view.
kind of need a budget for that stuff, don't you?
Yeah,
It makes a big difference.
makes sense.
Or no
And,
budget and a lot of imagination.
but and I was thinking about that when I was watching the first season of Stargate.
Yeah.
You SG1, you don't have
Nothing.
anything.
No.
And because I was super afraid, saying, "Okay, I'm gonna start a series that is from 1997.
I know.
The special effects might be a little bit hard to follow, so I
My
tried to
son
hang
mocked
to."
me mercilessly because I showed him some of the Atlantis stuff, and he's like, "Oh man, Dad, what is this like ancient?" Because of course the effects have moved on so far. It's amazing.
Yeah, it's ancient technology.
Yeah,
That's
exactly. Ancient
that's part.
technology. Ah, look at you and your references. Very good.
But
Yeah.
but yeah, so I was watching it, and they added some special effects more in the season. And I
Mm.
remember an episode in season 3 where you saw that they were running in front of a green screen, and I was saying, okay, this is the old special effects
Oh
that they
yeah.
managed to avoid in the first season, and that
Yeah.
they are building up, and it doesn't work anymore like this.
It's funny, isn't it? I find this with AI as well, where I feel like AI is being thrown at everything. And in the same way that in film and television, we threw visual effects at everything. And those films, they dated. And the series, they dated immediately. Like basically by the end of the season, the effects were out of date on many things. Whereas the ones that relied more on practical effects and that didn't just sort of uh, casually add effects whenever they felt like it. They hold up longer. They hold up better, I think.
I had the same discussion with a friend not so long ago, and you have other issues because everything is based on makeups and so on, and sometimes you see the actor moving and the makeup and the prosthetic
Yeah,
just
yeah.
folding not in the right way. So
I always like the way the Daleks always wobble a little bit because there was a guy in them trying to walk, trying to make them move. But again, I prefer the this is a Guillermo del Toro thing as well. Guillermo's always talking about he prefers the something there, like something concrete, the makeup, I mean obviously it's augmented by the science by the effects and stuff. But
yeah, I found it amazing the all the Nolan movies, and every time he's trying to do something even crazier in each
I
of his movies.
know. I know.
The
I
la-
wish he'd get off his film kick though and just go back to digital because the film seems like such a waste of time and energy to me. You know, I have no love for film. It was always more complicated than I love how I just watched a film the other day, Train Dreams, which is just beautiful, somewhat depressing, but beautiful, all outdoors, no sci-fi or anything. But it because that camera can pick up light that even I think human eyes would have a difficult time doing. You get these shots that are just would be impossible on film, So, um, all right, let's. There's an elephant in the room we need to discuss, and that is all of the badges on the wall behind you.
Oh yeah.
How far are you running?
My longest one was a marathon.
Wow.
But yeah, I think that is linked to what we were discussing just before.
Mm.
The I'm not running to lose weight. I'm running to avoid taking some. I had some friends that have this theory too. That is eating more, running more to eat more.
Yes. Yes. They say it's actually a problem that when people like myself who decide they want to get fit will start exercising, and as a result they'll go like, well, I've exercised, so they eat like the 2 pizzas instead of just one. So but that's no, if you've got that many on the wall behind you, you must love it.
Actually, I started running not just kind of by default, because when I was a kid, I played a lot of time football.
Oh yeah, that would
The,
be
the one with the
football,
foot,
the
by the way.
real one.
The
Yes.
one with the foot. It's
Yes.
in the
Yeah.
name. It's supposed to be played with.
For us for the Americans among us, that would be soccer and
Yeah.
wrong. Yeah. Yes,
So
football.
I was playing soccer, football,
Mm.
for a long time, and just with the studies, it started to be complicated, because the kind of all the team sports, you need to have your team, you need to have an opposing team, so you need a lot of people at the right time, at the right place, to be doing some sports. So it was more complicating during the studies, and at some point, I still wanted to do a little bit of sports. So running is an easy one. You need shoes. I started with shitty shoes, and it was not.
Oh my god, it makes a
best of
difference,
the
doesn't
ideas.
it? Yeah, I used to run, and I knew when my shoes were when I needed new ones, because I'd be hobbling around after after the run. I haven't really run for years now. I just don't. It doesn't. I feel like my knees can't take it, but that may just be an excuse. The thing I loved about running was just being out with your
Yeah.
own brain. I mean, it was just I mean, I'm often listening to music and stuff. Do you listen to music or podcasts?
Yeah.
What do you do?
No, always music.
Oh, music. Yeah.
That's one of the things that we might talk about. One of my other hobbies is DJing, and
That's right.
usually when I prepare, when I download music for that, I put everything in my on my watch to go running with it, and I just listen to the thing that I can play in the future, just to know a little bit about the stuff.
Let's talk about the DJing, because I think I'm fascinated by it, because it seems like a perfect combination of music that I love. Most of it dated '80s stuff, and also there's a wonderful sort of technology connection to it as well. Like, I love all the sort of pioneer turntables and stuff. What are you using? And what are you into?
Yeah.
I saw your video, which I'm not allowed to share because it's old, I know, but and I was really impressed. I mean, like, I think you could be DJ FPGM or whatever the heck.
Yeah, actually, that's one of the things, because I told you also, I'm teaching a lot in the different clubs and so on that I am, and that's one of the things that I tell people. You need to differentiate a lot of things when you talk about DJs, because the first thing you get in mind when you talk about DJs is the super known guy that is on top of the stage and so on.
Yeah.
So those guys, they are known. A lot of them knows really well how to the DJ stuff, but they are more known for the music they create. So that's a different thing, and that's one of the reasons why I will never be known for this for my DJing stuff. It's just that I like to play with other people's music, and to try to make some complex things out of it, because
but you were doing that, like that. What you were doing in that video was making your own stuff out of it. I mean, wasn't it?
Yeah. Basically, yeah, you can put just some points in the music and jump back and forth, and think about all those stuff. And that's the thing that I liked a lot at the beginning with this, because I don't have any background in music. So the thing that I really liked was the fact that that it's easy. It's you have a recipe, you apply it, and it works. And then you can try, if you want to improve yourself, you can try to just have more complex
You
riff.
sort of iterate as you go.
Yeah. And yeah, that I'm learning things every day. And the sorry, the we talk about the gear, and the gear is also evolving.
Mm.
And I was discussing with someone not so long ago, and you have, for example, with AI now, on the production software, you have some easy the music production software. You have some easy stuff to separate the different elements of a track, so you
Oh
can get
yeah,
the
I
voice on
love
one
that.
side and so on.
You can pull out the vocals and just have the background. Oh yeah, yeah.
And I already really love when I'm DJing to put vocals on top of other music,
Yeah,
so
yeah.
to do my own stuff. And but it's complicated to get the vocals. So
Mm.
I guess with the software, those software, you will be able to get more
Yeah.
these more easily. But I'm saying that I'm hoping that in a few years, the hardware that we use for DJing, so
Mm.
the Pioneer stuff mostly, they always try to improve to get a new to get new things in there.
Mm.
And I guess one of those things at some point will be the stem separation, and you can say, okay, I
Mm.
want to play
Mm.
this track, but I want to play only the voice part, I want to play only the
Mm.
drum part, and so on. So
I feel
yeah,
like there's specific AIs for that now because I was looking into that. There are actual like, I mean, I don't know how legit they are. There's so many. I can't keep track of the AI. The AI stuff is so fast, but that there's AIs now that you could put the music in and it'll pull out the various different stems for you. Or also the other one is it's kind of fun to take AI generated riffs and then incorporate that into other stuff as well. I mean, again, I've not done any DJing, but I love. I remember when GarageBand first came out, I was like, "Oh my god, it's everything I wanted!" Because I was in a bit. I had my poor guidance counselor at high school. I'm grade 10. I'm failing out of everything, and I sat down with the guidance counselor, and he said, "Okay, David, well, let's talk about your options here." And I said, "Yeah, I don't know whether I want to be famous as a drummer or famous as an actor." And he just, I saw his face just go like, okay, we're done. None of that relates to school at all. So yeah, luckily I went with the acting because the drumming I was never very good at keeping the beat. But yeah, I love the technology side of that. I feel like I could lose myself in that. Are you doing it? Are you still doing the DJing stuff at all?
yeah, we created a club inside ESA with a few colleagues.
Oh my
So
god!
yeah, we are
Well,
doing it. That was a nice thing because, for example, for the we celebrated the 50 years of ESA last year,
yeah.
and one of the events, they invited us to play, so it was super nice. And
How did
yeah,
I miss that? Was
that
that
was a
ESA
private
Open
event.
Day? Not ESA Open Day.
No, it was
All right.
afterwards.
You got to. So I got to. I'm. Yeah. Okay. I've got to start sharing schedules with you because I want to come. I want to come listen. It was funny. One of my favorite 3D printers is the Prusa. And partially because I just love Josef Prusa, the guy who invented it, and not invented it, but basically iterated an open source build. And he's a DJ as well now. He does his.
Hmm.
I was at a convention in Prague, and he came in and did. Well, and laughed at me because I was going home because I'm an old man, but he was just starting to go out to do his stuff, and it's amazing. Do you do any live stuff? Do you do any like no, obviously you do live stuff. Do you do any live streaming stuff? Do you stream any of your?
I, I did it a few times during COVID, basically because no gigs and
Yeah,
so on,
yeah,
and
yeah, yeah.
but I don't have any cameras, and I used to do it with an old phone, and it was not a great quality. And yeah, and as I with COVID, I dropped a little bit. I just restarted basically when I met my
Mm.
colleagues that like it also at ESA, and so I'm just back in it for a few months.
I
For a
love
year
it.
now, I think.
I, I love
But
that you're doing it because it's the opposite of what you're doing at work in a way. Like it's forcing you to. It's like you can't have a plan, can you? I mean, you can't. I suppose you could plan it all out. I suppose, but you don't really, do you?
yes and no. It depends. That's one of the also the things that I discuss in the course. I guess it's also it depends. Like the radiation
You
stuff a
love
second.
that answer.
No, but you can have let's say I what I did is when I have a gigs that is less than 20 minutes
Mm.
with a lot of people around, then I like to plan stuff and to
Yes.
do
Yeah.
complex stuff because
You want to show
you
off in
need
that
to
20
show
minutes.
off a
Yeah.
little bit so that people can say, okay, I really like what you
Mm,
did, and so on.
mm,
But yeah, when we were talking about the different types of DJ, I'm more the one that likes all the technical stuff and so on. So
mm,
I'm trying to prepare in a way everything when with my music, so
mm,
that I can try to say, okay, now I would like to go a little bit in this direction. So maybe I know how to find my music, and I put these filters on, and let's see what I've got. Oh, this one, let's try with this one. Then I put this one on that side. Okay, let's try to do something with this together. Okay, it fits. Let's try to find the next things, and so on. So you
you
so
plan so that you
yeah,
can then enjoy spontaneity when it happens.
yeah, and really that's that was a really big gap, because yeah, I had the two different thing, only playing long gigs, and you
Mm,
just go with the flow, and playing short gigs, and then you try to prepare everything. And then this in between, I was always, when I was playing the short gigs, I was saying, oh, but I remember, I wonder if one day I will be able to just start a set without anything prepared and manage to get
mm,
this level of stuff. And yeah, now I like to be most of the time just free running,
mm,
and then I try to do those stuff. And then the drawback is that you make a lot more mistakes when you try to do those stuff and prepare
mm,
them more complex. But the thing that I've learned with experience on this topic is that a lot of things that you think that you failed, people don't even notice. So I remember for the 50 years of ESA, I thought I failed big time. And for the next week, I had a few colleagues that were telling me, "Oh, it was really great," and so on. And I was in my mind, "Thank you, but I
but you're
messed up
wrong.
what I wanted to do."
That's so funny because I mean I think I, it's a bit like the writing and directing where I feel like it's the happy accidents that you can't plan that are, and because of that they're just they're out of left field. They You get these wonderful little accidents that can
That makes
make
it real.
that makes it art. I mean, like that's the
Yeah,
point, right? I mean, if it's like when you see some of these big Hollywood movies where everything's being planned out, everyone's been all the best people have been hired, all the best this and that, and it's just like it lacks a soul. You know what I mean? You want a little rough edge here and there. Wait, I'd love to see. I mean, one of the things I started doing is looking for DJs to watch on like YouTube, like watch a live stream or Twitch or whatever, that kind of stuff. Because I'm just sort of curious to see how it works. I even thought about taking a course, but that seemed like so grandpa. Oh, grandpa's taking a DJ course. I just
actually no, really just. When I was doing doing my courses in my previous course, you really see every age. I had I was
Oh, did you
one of
take a
the
course?
students.
Did you take a DJ course?
No, no, I was giving them, but
Oh, okay.
the, for example, the student, there was a 10-year-old boy,
Yeah.
there was a 50-year-old
Not
dad.
50. Boy, that's old. Well, I didn't realize you taught. Well, so there you go. Where do you teach? Is it online or is it like live? Do I
In
have to?
the ISA club.
Damn it! I'm moving to the Netherlands. That's it. Who do you have favorite DJs? Do you have people you like? I mean, who do you any sort of standout people?
Yeah, then you need to once again split between the music they make and their skills. For the music they made, I'm kind of at some point I really liked future house style of music. So it was more led by Don Diablo back then. I really liked that stuff because yeah, it was giving me emotion, you know. And since this time, I really didn't find anything that's as appealing as this to
Really?
me. Uh, I'm starting to like more and more drum and bass. So it's yeah. eh, but I still don't have this odd feeling that the more I
Mm,
play, the more I play, the more I like it. So
mm,
on the music side, yeah, so I don't have any favorite artist right now on
mm.
drum and bass side, but yeah, I used to have some.
Th-
But
th-
on the DJ side,
yeah,
on the contrary, then you can just focus at yeah, you have more stuff. I think that there is a guy called James Hype, and on
James.
the technical side, he's super good.
Yeah.
And so I really like to watch him playing, to
Mm.
watch him do his stuff. The the thing is that I'm not a big fan of his music.
Ha. Oh, that's
but
interesting. So
I'm
you like
really
his
a
technique,
big
but not his
fire.
music. Yeah.
Yes,
Hmm.
its music is not bad, but it's not my style at all.
Yeah. Yeah.
That's just the thing. But yeah, really technically is really good, and I really like to see some of the kind of things. And one of the things that I'm super happy about is that, for example, I remember seeing him seeing a video of him doing some trick, and I said, "Oh, but I managed to do this trick once." And you see that some tricks that you manage to find, they are all around, and so
And you
that's
see
super
them
interesting.
being so. There's definitely like a repertoire for this stuff.
And yeah, and the other thing is, because when you think about DJ, you think about the music, but
Mm,
you need to think also about the shows. So
mm,
when I was learning and so on, I also had a few lessons about the lightings and so on. And
yeah.
it's such a big difference in
Yeah.
shows. And I've been to big concerts and so on, and you see when the people make a
A
show that is
spectacle of it.
super
Yeah.
great. Yeah,
Yeah.
it's as good to see as to listen.
There's a theater to it as well. Yeah, I agree. I think you need. It's not just that.
I think I've seen a DJ once. I'm not sure that everything was live, but because everything was really prepared by the
Mm.
minute, you have some videos of some elements and so on.
Yeah.
But it was telling a story all along, and I thought that
Oh.
it was super good because that's that's kind of the blurry line behind the art. Because yeah, maybe it's not as much DJing as it is, but it's stage
Yeah,
preparation,
you're
and you
making a show. You're putting on a show. That's in a
yeah.
way, yeah. Why not? I mean, like that's
And I think it's as hard as anything else, because yeah, just my small experiences with the light, you have so many possibilities,
yeah.
and you need it
And the
to
pyrotechnics
make
when they
it
get the
work.
fog going and the
The
flames, that stuff's awesome.
craziest thing that happened to me, the 50 years of ESA, that was the first time that I had just the sparkles on the side. I was, oh my,
I want this all the time.
yeah.
Uh, I've actually got a question for you. Super Cryo's got a question for you. As someone who's both an engineer and a DJ, do you feel that music helps your scientific or creative thinking in any way?
I think so, because I notice, especially when I'm far from holidays, I
Mm,
notice that if I just stare at my computer and don't do anything, and try to do something, my mind will fly away and I can't focus. But every time I put on my headphones, put some music in the background, I can just work without.
mm,
It helps me so much focus. That's
mm.
really a big thing.
I've definitely found that separating myself, like there's a certain part of life that is just you just got to bang your head against a wall and get the stuff done. You got to grind through it. But often, I find when sort of give up for a second and go take the dog out for a walk, or I go listen to a song or something, my brain will figure stuff out for me. Like I think sometimes you can. There's some stuff needs to be forced, and there's work that has to be done. But I think, as you say, the idea of being able to focus on something else can often sort of like just sort of get that log jam moving
Yeah,
again, you know?
I think that is two different kinds of work, because the work that I was more talking about is just you have a specific goal, and
Mm.
you have to reach it. So you know where you need to go, headphones on, yeah,
Yeah.
full steam ahead. But sometimes I'm trying to write some more experimental papers and so on.
Mm.
And in this situation, I need to get all the information all around, not trying to work too hard on it,
Mm.
just getting all around and just doing something else and thinking of it in the background.
Yeah.
And then you see, okay, so the best way would be to take this piece of information, this one and this one, put them together this way.
Mm.
That could work. And that's also when it's super important to have super nice colleagues, and I just something bounce my
Yeah.
thinking with them, and
It
super
it's funny,
nice.
isn't it? It's very easy to get into the doing of things before you've got a sense of everything. I mean, there's just I'm very quick. I always found that with my programming, with whenever I had to do programming something, I would always end up diving into the programming before I'd really figured out what the program was going to do.
I definitely relate to that, because
Yeah.
I, I
Because you're excited
noticed
and you're
that.
impatient. You know what I mean? Like, yeah.
Exactly. I noticed that at the beginning of my work, I was always doing such thing, going there and so on, working for hours on a problem. And at some point, you discuss with a colleague saying, "Oh, I did that, and that," and it tells you, "Yeah, but we need that." And you said, Oh,
Oh, right. The
so I
obvious,
did
the
all that
most
for
obvious.
nothing.
Yeah, I know. I know. Well, that's the trees for the forest, right? You miss the trees or the,
So
yeah.
every time I'm giving some advices to some other people, I'm always telling them the most important thing when you work, just take a step back from time to time.
Hmm. I think it's
It's
important.
not
Yeah.
it's not loss of time. You may think about it like this because you're full steam ahead, and if you stop, you might miss something. But it's important just to stay a step back. And yeah, I was saying that to a few people not so long ago, and just ask one question. As an
Mm.
engineer, I always ask only one question. It's why am I doing this?
Yeah.
Why is this written this way? Why is this? And when you go to the last why of the list, you are sure that you are on the right path.
That's it. I think there's actually a business book called the something about asking why. I remember reading
Ah,
something
okay,
years ago that was just literally about that,
interesting.
like just drilling down with why. Ivan Skvortsov has a question that says, "Do you ever mash up classical music? Do you think that's something that even makes sense to do? You use any classical stuff in there, or is it all more contemporary stuff?"
Uh, no, you already see classical music in kind
Yeah,
of
I
hip
feel
hop
like I've
music
heard it a
because
couple times.
they get a lot of samples from there, and there are a lot of hip hop songs with just a bit of classical music
Hmm.
gone in repeat that sounds super great.
Yeah.
And I have a friend that is fine to classical music,
Mm.
and he's a really good friend. And sometimes we discuss about all those things, and sometimes he shares me electro remixes of classical music that he
Yeah,
says, "Oh, I
I
don't
love that
understand that."
stuff.
And on the contrary, I send him other stuff, the nice usage that I think of classical music. And yeah, I get his point that my friend's point is that classical music is it's an history, and you don't have too much repetition. So
Mm-hmm.
that needs a lot of work for sure. And those composers was just amazing.
Mm.
And the electronic music is on the sampling is just you take what you think is the signature
Yeah.
of the sound, and you put it in there. So yeah, in my different songs, I have a lot of things that I just put a small tag saying melody or some or sample, just to say when I'm putting a song that I know
Mm.
that it lacks a little bit of melody or so on. I just go on this folder and grab it to put it on.
Mm. Oh God, no, that's amazing. Now it makes me want to do this. Now I gotta go look. I gotta look more into this. I also want to see you do it. Like, so that's we gotta like. You have to like. Maybe we'll do like a. Maybe we could do like an I'm with Stargate Genius dance fest or something. Like we'll do like a live rave or something. That would be yeah. That's amazing. Look, I shouldn't keep you any longer because I realize it's been 2.25 hours that I have kept
Ah,
you talking. This is amazing. This is the problem is now I want to now program chips for space and do marathons and also do DJing. So yeah, I don't have time for this. It's absolutely amazing.
yeah, I don't have
Yeah.
time to do everything
I should
myself.
say thank you to the raid. We've had a couple of raids apparently during this, and I've ended up with over 300 people. So thank you so much to everybody who's joined
Hello,
us. I
everyone.
apologize. This is these are my I'm with Stargate Genius chats, and I like to talk to our guests. So I tend to sort of ignore the chat while that's happening. But thank you so much. That's what an amazing turnout. See, there you go. You mix a little space, a little DJing, a little exercise. We got this. We got this down. Gaetan, thank you so much. How do people get in touch with you?
Thank
Do
you
you
for the
want them
invite.
to get in touch with you? What's the how do they keep track of what you're doing? Where are you at?
They can feel free. I saw that you put my
Yeah,
LinkedIn in the
yeah. What
description
about the DJ
of
stuff
the
though? Is there a way to
videos.
get hold of you for that stuff or what?
That's the thing. I told you that every time I'm trying to do thing, I do a lot of small mistakes that I notice them. So I stopped recording myself. I might, as we said, go back to the streams at
Mm,
some point, but I've no setup
yeah,
yet, and so there is. You could find my old
yeah.
stuff with mistake in
Okay.
there. If you do, please don't
Don't judge.
d- don't
Right,
highlight
right.
them. I highlight them myself
Yeah, that's
enough.
the story of my life.
But
That's all I
yeah, there
do is
are
highlight the mistakes. It's one of the reasons why I like doing the live
the,
streams is because I feel like there are so many perfect interviews. There are so many perfect podcasty chats and stuff. I just want to talk to people. Like I think there's a, and if it's too polished and it's too organized, I feel like it doesn't feel like humans talking anymore. It feels like a TV show. So that's my excuse for messing everything up this morning, anyways. All right, Gaetan. So people can check you out on LinkedIn, and obviously go check out ESA and see what's going on over there, because there's some great.
And get ready for the
Yeah,
open
and
days.
open days are a must. Like I've said this every time. I'm going every year now. Like I've just like that's it. Whether I'm invited or not, but don't tell them that. But I'm showing up because I just love it. I love it out there. It's amazing. I mean, are you in Leiden? Are you in around there as well, or are you?
No, I'm in Katwijk, so really just in front of Aztec. I can see
Ah,
it from my
that's
window.
great. I just freaking loved it out there. Just loved it. So looking forward to going back. Uh, Thank you again, Gaetan.
Waiting for you.
Thank you, obviously, to Agne, who is now learning Dutch. Thank you again to the amazing chat. That's like I can't believe how active this
Thank
is.
you, everyone.
You've definitely got some imaginations going there today, Gaetan. So thank you all. I will wrap this up. I will say, until we geek again, I will say, be brave, be kind, be brilliant, cheerio, and huzzah. And thank you so much, Gaetan. That was amazing.